Good morning, IoT Builders. We are live from Embedded World 2023 from Nürnberg, Germany, and this is the last day of our live stream. My name is Alina Dima. I'm a senior developer advocate in the AWS IoT Ecosystem Services team, and I'm here with Richard Berry, senior principal engineer at AWS, and also the creator of FreeRTOS. Hi, Richard.
Good morning again. Nice to be here again.
Nice to have you here. So what we're going to do today is start with a summary of the topics that you've seen yesterday. So yesterday, just as a little recap, was the day of observability, security, and functional safety in embedded systems. Really important and interesting topic.
Absolutely, yes. Especially the observability. I think anything which helps people be more efficient in their development is
Yeah.
So I say especially observability because yesterday I was focusing on security. I'm also security is number one.
Yeah, so we had really interesting participants yesterday. We kicked off the day really early in the morning, of course, with Syed doing a summary of the previous day. And then we went right in with Johan and Mike from Percepio talking about observability in FreeRTOS applications with their products Tracealyzer and DevAlert. Interesting products, right?
Absolutely, yeah. I mean, I've worked with those guys for some years, and the insight that their tool is able to give you is amazing. It can save just to see the pattern of execution of how your system is running in the first place can save so much time. And it's amazing how often you think your application is working in one particular way, and then you look at the trace in Tracealyzer, and actually it's not even what you imagine. So I mean that's just the start of what their tool can do. So I'm a big fan of that.
Yeah, so they went into details and they mentioned that Tracealyzer nowadays actually has support for finite state machines as well on the device, so you can actually see not just the event logs, but you can actually see the proper state machine and the state transitions as well, which is very interesting. I think it's a good tool.
We have this kind of cloud post-mortem capability, if I can put it that way. I'm sure they don't describe it like that, where something happens in a deployed device, you can actually retrospectively analyze what was going on.
Okay, yeah, that's really interesting. Then we had a session about open source software for connected vehicles, and here we had the director of research and development for DXC, and the talk was about providing efficient value across IoT Edge and the cloud backend and the data management aspects across the connected vehicle. So very interesting topic. Watch it if you haven't seen it. And then we moved back to FreeRTOS, and we spoke about FreeRTOS for industrial automation with OPC and here we had the VP of Global Product Group Manager at B&R, and we also had our colleague Andrei Buzescu, Strategic Partner Management for AWS IoT. So it was an interesting conversation around the collaboration work that AWS is doing with 7 leading industrial automation and semiconductor companies. So it's around acceleration of IT and OT convergence.
Yeah, what we're trying to do there is really kind of downsize OPC on TSN, the time-sensitive networking. What we're doing with that collaboration is trying to create, or we are creating, an open source stack which is much smaller than anything that's available today, so we can bring it to field devices as well.
Okay, yeah, cool, interesting stuff. Right, and then we started talking about embedded device CI/CD with Arm virtual hardware and device advisor. And here we had Elam, a cloud engineer from Arm, and David Walker talking about how to leverage Arm virtual hardware when you don't have the actual devices, so that you can continue your development, you can do deployments, you can do testing, and so on. And also an interesting aspect was around IoT Core Device Advisor and the integration tests that one can run before deploying the firmware to actual production devices. So very interesting stuff again. Right, and then Sternum, the CTO of Sternum Lion, was here, and he actually, introduced the development kit for FreeRTOS for embedded runtime security, continuous monitoring, and threat detection. That was a really interesting talk that we had with Lion.
Yeah, it's great. It's great that these security tools, security in IoT is just so essential. Security in everything is so essential.
Yeah.
I'm focusing on the device side here, but it's great that these really good tools are coming to help. It's not security can be a bit nuanced, and you need specialist knowledge and all that kind of thing. So the more tooling there is to help our users, the better. And so it's really good to see.
Yeah. So I think what's interesting about Thermum is that they managed to mix security and observability in the same product, which is quite exceptional, I would say. So this tool actually allows for tracking and monitoring of device at device level and at fleet level as well. So you can get remote visibility into device performance and analyze that. So it's really cool. Right, and then we had a session with the CTO of Eurotech, Marco Carrer, and he spoke about zero-touch provisioning and an integration, zero-touch provisioning integration between IoT Greengrass and devices. So that was a really cool and very interesting topic. So if you haven't seen it, watch it.
See, this is another IoT pain point that our partners are helping with. Is integrating the software is only the first step. Yeah. How you take that to production, kind of AWS scale, then you have to do with the provisioning and the onboarding and those workflows. And again, anything that helps those workflows is really welcome.
Yeah. So I actually saw a demo of this mobile phone app. That the operator would actually take with him when sort of onboarding the device, and how easy it actually is. 3 button clicks, and the device is already provisioned and ready to go. So I think it's super work. Right, and then we had a session around Sophie and the cloud native car with the director of Linaro and the CTO of Linaro. So this is about the collaboration, the industry-led collaboration defined by automakers, semiconductor suppliers, open source and independent software vendors, and the cloud technology leaders. And it is about delivering a cloud-native architecture enhanced for mixed critical automotive applications with open source technology. So really interesting work. And if you want to learn more about this project called Iceberg Blueprint, this was discussed yesterday as a case study.
And I think this might kind of circle back to the virtual hardware as well, which is used. I think is used in that project as well.
Okay, really interesting. Cool. Yeah. Right, and then we had a couple of sessions on AGL and how to build for AGL and how to develop automotive solutions with hardware abstraction techniques. Also very interesting discussions. Another session on PyTech and rapid development of cloud-connected industrial machines. Also a very good talk around connected industrial automation. We also had Joseph, the head of developer advocacy at Mender.io, and he spoke to us about system updates versus application updates. What is the difference there? And the difference between machine data, important for device management, and process data, important, of course, for the use cases that you can build on top of IoT. So we covered, integration between the Mender solution and AWS IoT and how this connection works. We also covered this A/B partitioning mechanism for doing firmware upgrades. Very interesting chat, and Joseph is always very entertaining on camera, so we had a really good talk. Right. Anything about firmware upgrades you'd like to mention, Richard?
Well, I keep saying all these pain points that people have. I mean, you can't have security without firmware upgrades, right? So again, it's an essential thing, and the whole ecosystem, partner ecosystem is it's great that we can give these people some airtime here, so you can learn all these things exist, because it's going to help.
Yeah, absolutely. Right, and then we moved back to AWS IoT Device Defender and AWS IoT Device Advisor and the solution from Kikatek. Leveraging the Device Advisor test framework, to test their software before going to production, to make sure that their MQTT connection is reliable, to make sure that the TLS handshake works as expected, to run long-running connectivity tests and make sure that the device stays connected. It's not just connected temporarily, but stays connected. So yeah, really interesting talk there as well. And then we got to a very good discussion around functional safety and functional safety tips for developers, especially the question of how you start developing with FreeRTOS and end up with a safety certified device.
Yeah, so this was, I believe, by Andrew Longhurst, someone an old colleague from a few years back. I worked with them for a long time, so it's good to see them here as well, and we were able to give them some airtime. So again, this functional safety for becoming more and more important, right? Especially in high value IoT use cases, if I can put it that way, industrial automation, automotive. These where there's a lot of data and some kind of safety requirement as well, then this is a really good option for people.
Yeah,
so they're a strategic partner, and they fill that gap really well.
Yeah, really nice. So if you missed this talk, this happened yesterday in the afternoon, so you can scroll straight to the video of day 2 and watch it. If you've got any questions on these topics, feel free to leave them in the comment section and we will get back to you with answers. Yeah, and the last session of the day yesterday was around AWS IoT ExpressLink and our famous demo badge project, which everybody knows and loves. So this was session number 2, and it went deeper into the details of achieving a connected product and the different iterations that the team made up of Joe and Thomas went through to implement the badge project.
And this is, I talk about ExpressLink a lot. To my mind, it's a step change in simplicity. In all the things we've been talking about, right? The onboarding, the security, the over-the-air updates, time to market. It's all kind of handled for you here. So I amplify that all the time.
Yeah, no, absolutely. So really good service, and really good at making the developer's job easier when integrating with AWS IoT.
So, another great example of working with partners as well. People who are providing these modules.
Yeah, absolutely. Yeah, so this was yesterday, the summary of the day, and after a short break, we are going to go into what's going to happen today. But before we actually pause a little bit, I'd like to ask Richard if he's got any last words for today.
No, well, I'll say no, and then I'm going to say something. The last day is always a fun day. There's a lot of students around, and it's great. It's great to try and pass on our enthusiasm to the next generation. So the last day is a little bit more relaxed for me, so fewer meetings. So I'm looking forward to it.
Very nice. Yeah. So today I have a session in the Expo on ARM virtual hardware, CI/CD, and integration testing. So if you are at Embedded World, come by Forum 3A at 11:30 a.m. For that session. Thank you very much, and see you after the break.
Thanks.
Hi, IoT Builders. We are back live from Embedded World 2023, and it is day 3 of our show and also the last day of live streaming from Embedded World. We are all really excited to be here, we have a bunch of really interesting episodes popping up today. So just watch us, watch the episodes. It's going to be a day full of observability, debugging, FreeRTOS again, ExpressLink, and how to build with ExpressLink. So it's going to be a really interesting and fun day coming up today. So what I will do now is go through the sessions of today. So our, little 20-minute episodes that we have already, been used to. So what we're going to do as a first episode today is talk about device reliability engineering with remote debugging and monitoring at scale. So a very important topic for developers, how to debug remotely, how to do monitoring of your IoT fleet at scale. This is going to be a talk with Memfold. So Tyler is going to be here talking about, companies needing the ability to remotely debug issues for production as soon as they kick off product development. So this is a bit of an afterthought at the moment, but it's starting to change, and it is an important habit to actually work on changing. So this is going to be a talk about best practices, how to debug devices during development and also deployment phases in production. So stay tuned. This is going to come right after this session. Right, and then we're going to have another session on developer tools. So this is again about Arm virtual hardware and the Keil Studio, and actually how to use the Keil Studio desktop and the enhanced support for Arm virtual hardware in order to to interact with, to test your application, to deploy it on test hardware before you get the actual hardware. Right. So what Arm virtual hardware actually enables developers to do is develop the software on a test and test it against the test hardware first before going and putting it on the physical hardware. So you can spot problems, catch bugs really early on. And of course, because of the cloud capabilities of CI/CD and machine learning service support, it's just a really powerful tool. So stay tuned. We're going to have Christopher Seidel from Arm, and it's going to be a really interesting topic. Right, then we're going to move a little further towards ExpressLink again. So we're going to have a session on with Telit actually, and it's going to be a session on building awesome IoT ExpressLink products. So again, very interesting. Martino is going to be here. He's the head of product at Telit, and he's going to talk about how to build awesome products with ExpressLink. Right, so you heard Richard Berry earlier, ExpressLink, a service very dear to his heart, and a service that makes the developer journey with AWS IoT a lot easier and, a force for acceleration on the journey of provisioning and ensuring security and so on. So really interesting topic. Then we're going to have a session on smart camera software frameworks. So this is going to be about the newest software development paradigms related to smart cameras. And here we are going to have somebody from Arm. We're going to have Parag, who is a director of segment marketing in the IoT line of business at Arm. And this is going to be, I believe, a session moderated by Syed, really exciting. So stay tuned. Then we're going to be talking about open source and IoT and Edge. Can you imagine all together in the same episode? This is about the Eclipse Foundation, and it's actually quite an interesting fact that I myself didn't know, that the Eclipse Foundation is home to more than 425 open source projects. And these are not the Eclipse IDE, surprisingly. So in fact, more than 50 of them are related to IoT and Edge. And this is what we're going to be talking about today. So we have Frederick, who is a program manager and evangelist for IoT and Edge computing at the Eclipse Foundation. And in this conversation, it's going to be a lot of open source talk and how the open source movement has actually impacted the development and implementation of IoT technologies. So very interesting. Stay tuned. It's going to be a really good episode. Right, then we're going to switch back to ExpressLink. Can you imagine? It's going to be a talk about making connected products with the STM32 microcontrollers and AWS IoT ExpressLink. So developers are accustomed in general with STM32 microcontrollers and tooling. So now it is all about how to get them accustomed to using ExpressLink with these microcontrollers, right? So this is figuring out how to pack the code for ExpressLink, how to allow developers to generate the project with zero code, and so on. Right, and then the closing session is going to be, the already known and loved IoT Badge project with ExpressLink, and we are going to have the last session of the series of the Badge project and AWS IoT ExpressLink. So this is the part 3 of building the fastest path to connectivity, and how the AWS team made of Joe, who is an engineer in the IoT service team, and Thomas, who is a solution architect at AWS, how they paired together to actually build this badge project and develop it with AWS IoT ExpressLink, and they are going to mention the workshops that you can do and all the material that you can use to learn about AWS IoT ExpressLink. Right, so this is what we have in store for today. It's still really noisy here at Embedded World. It's a lot of buzz, even if it's the last day. So the atmosphere is still pumping. If you are around, let me mention it again. If you are around at Embedded World today, I have a session in the expo on ARM virtual hardware and CI/CD and how to do continuous integration and deployment, and how to leverage IoT Core Device Advisor to run integration tests and test your MQTT connection before deploying the code to production. Yeah, so this is all the summary of what's coming up next today. Please stay tuned. The next session is going to be, as I mentioned, on device reliability engineering with remote debugging and monitoring at scale. Very interesting. For now, stay tuned, and we're going to be back shortly.
Hello and welcome back to the Embedded World live stream. I'm Nenad. I'm joined today with Taylor, and we're going to talk about device reliability engineering with remote debugging and monitoring at scale, right? So maybe Taylor, you can introduce yourself, we'll jump into the questions.
Sounds good. I'm Tyler. I'm one of the co-founders of Memfault. I come from a firmware engineering space. I've been doing this for 9 years now. Had my career at Pebble, the smartwatch company. And then Pebble got acquired by Fitbit and did a bunch of firmware there, but I kept finding myself building developer tools. And instead of writing firmware, kind of writing tools for the firmware developers to make them faster at their jobs, whether that's Python scripts, backend applications, CLI tools. That's what I loved, and also like where my impact was. Kept seeing this as a trend across the hardware and firm industry, and then that kind of inspired us to create Memfault with 2 other coworkers from Pebble, and then we quickly hired a bunch of other people from Pebble and Fitbit. Not stealing, but they left, and yeah, so we're at Memfault trying to do this for all the developers and firmware developers and hardware companies all across the board.
Excellent. No, yeah, one of the things developers need to do when they're developing is kind of debugging. So maybe you can talk about like how you solving that problem, debugging in production and
So when you build a mobile application today, or a cloud application, or on some standard system, there exists a bunch of tools. You can include the OpenTelemetry library, and you can say, grab me all the logs, all the traces, all the crashes, depending sometimes core dumps, but all that's pretty standardized, and it goes into some standardized systems, including AWS, I'm assuming. When you talk about constrained devices, those tools don't exist. And so I remember at Pebble, every new watch we would bring up, we would have to literally write the code that prints characters to the console.
Yes.
Write the code that streams logs to the flash chip and then pulls those off the device. And that's just like step 1 of step 20 that you can implement on the debugging lifestyle. Or cycle, I would say. So Memfault is kind of one of the companies, or maybe the only one, providing these sorts of out-of-the-box tools for hardware products, for firmware engineers, that can get them up and running really quickly. And the benefit of all of this is it doesn't require wires. You don't need JTAG, you don't need a serial port. We assume that you have some sort of persistent storage on these devices, and whenever you have internet connection, send it back to us. And we'll process it.
No, this is pretty cool. I mean, it's like usually what you said, like debugging process for like constrained devices is like you have a JTAG and then you can step through, and that is kind of thought as an advanced thing, right? First of all, is like prints and logs and like on a serial console as well, right? But then, the question is like, how do you do that at scale? Like if you have like 10 devices, 100, 10,000 devices, right?
For sure.
So how you enable the developers to kind of inspect what's happening. So I mean, can you tell me about the issues you faced in order to develop that? Or how
For sure. Well, a couple things to begin with. I think the state of the art in the industry has been logs. And so I've attended a number of talks, mainly out of curiosity, for people who pitch logs as like the next level of embedded development, just to kind of to understand what people are talking about. So I would say memfault is beyond that. And so yeah, like to your point, how do you go from 10 devices to 100 devices?
Yeah.
Usually what people do when they have logs is they shove them into an S3 bucket. A developer has a Python script, they download those logs, and they're on kind of a case-by-case basis. But when you have 100 or 1,000 devices, that's never going to happen to detect trends. And are all these devices experiencing this particular log line, or is it just one? And so what memfault is kind of doing is processing all of the data, whether it's logs or core dumps or particular metrics like average battery life or uptime or your stack overflows and how many you actually get. Like we're analyzing that and aggregating it and saying, this particular issue affects one device, this particular issue affects all the devices. And that one is more important than just the one that's affecting one device. I mean, yeah, there's a lot of tangents we can go into here.
Yeah, I mean, I know like in like microservice architecture, you have like a Zipkin and OpenTrace kind of tooling to view all of this. But yeah, you're right. I never seen this in the industry before. To have like for the microcontrollers as well. So do you have like a dashboard where it's some kind of similar to like OpenTrace?
Yeah, for sure. And that's, I mean, I have a lot of favorite features in memfaults, but that's probably my one favorite feature is you can have a firmware developer who really loves firmware and who writes some code to instrument their device, whether they're measuring, if it's a smart lock, the number of unsuccessful locks or successful locks to kind of like do a product metric. And it can detect crashes. And then you can have somebody who doesn't know anything about firmware from the support team who logs into the dashboard and can use this really easy to use UI to debug these devices without knowing anything about firmware. And so what I have always worked with, even at Pebble and at Fitbit, was Python scripts. Everyone had to have a Python environment that was meticulously crafted. And if it ever got out of date, it would be really hard to run those scripts, to download files or run the big battery life analysis on 500,000 devices. But the dashboard makes it really easy for anyone to get onto it, onboarded, and always have the up-to-date version.
No, that's pretty cool. And then I'm wondering now on the device side, like, is there like an SDK or a library, or how does that work?
It's a great question. So we have for constrained devices, for MCU, we have an open source SDK library, a handful of files, 10 to 15, depending on how many features or what platform you're working with. And those are just C files. Anyone can download those. They're on our GitHub. You would include those files into your project, into your firmware that you're actually compiling onto the device and putting it onto it. And for the MCU side, there's no agents. Like the developer is in control of kind of when a lot of our code is called. So a lot of people are worried that it's going to start uploading random data or without their desire. That's not the case. So you're pretty much in control to collect when to send data, what core dumps to collect, what metrics to collect. It's just a very good instrumentation library that then serializes the data. It makes it easy to transport back to our service.
So you can use it like printf. Instead of printf, you can just use those calls.
Correct.
And then you say you have like is it like exporting this data in batches, or like how does it?
You'd be, you're probably not surprised, but you'd be surprised at the number of transports and hops people try to go through. So yeah, if we would hook in by default to the printf, we would collect those logs. For core dumps, we would hook into the fault handlers of the actual MCU that you're running on, whether that's ARM or RISC-V or Extensa.
Cool.
Doesn't matter which fault handler, we'd capture a core dump there. And then if the customer code or developer code is calling metrics, like if you're trying to track how long the Wi-Fi chip was on, you would metrics set on, metrics set off in the Wi-Fi code or controller code. All of that data gets serialized to what we call chunks. But chunks, it's funny, they have to be at least 9 bytes per chunk. But some customers will try to send a 100K core dump, but they'll send it up in like 20 byte chunks. And so we have a server on our end that then kind of stitches those all back together so that devices can send us data, because sometimes they don't have HTTPS directly. They have Zigbee, and then eventually those packets make their way to our service.
Oh yeah, right. So what happens if I was actually want to ask this about the connectivity. So if they don't have it, so how do they send this data? It's like somebody can just read it out afterwards, or like use Zigbee, or what you said. Like,
our SDK.
What are the solutions that you see in the industry?
For sure, our SDK produces bytes. And so we're pretty agnostic to doing whatever. Actually,
That's cool.
bytes in at least 9 byte chunks. That's what we do. And so we have a debug script that'll print it out of a serial if the developer is trying to test things first. We have a pipe that just allows you to stream it off into another data source if you really want to. We see customers do things on BLE mesh or Zigbee mesh to an ultimate gateway. And then the gateway is responsible for sending up every single chunk to our service. We have some customers that have a direct connection to AWS, and then there's a Lambda function that sends those chunks over to us. It's just like whatever people want to do, they can.
They can hook in there
and then forward the memfault kind of header chunks to us. That's all. Yeah.
And then for the cloud part you mentioned, is that like something that you manage or
memfault? Yeah, that's it's typical SaaS server. We manage it. We do all the hosting. We do all the scaling, which is great as well.
Yeah, of course.
Because
some people don't want to.
when I was managing the database at Fitbit, it was not a good time.
No.
You know, you don't want a firmeur person being a DevOps person.
No.
But some of
you can do it, but sometimes it's not the best.
and this is the thing, at one point it becomes debugging infrastructure.
Yes.
And then at some point it becomes production infrastructure. And so, at Pebble, we had a lot of information in there, like what was the user's current battery life over the course of 7 days, and all of these statistics, and which apps were they using, and which phone were they connected to, which random Android phone were they connected to. Both sensitive data, but also incredibly useful data that had become required for our support systems.
Yes.
Anyways, so now, as soon as that sort of happened at Pebble, the cloud team was like, all right, let's take the management of this DevOps system away from you.
That makes sense.
We can't handle the downtime anymore. But that's kind of why we also believe that the hosting solution is there, because
that makes sense.
if anyone else is managing this, like, they may not be able to handle 100 or 1 million devices daily.
And then I assume that there is like an authentication and some APIs, and then basically those are pumped in. Okay,
Exactly.
that's pretty cool.
And I have to add one more thing. The thing that people always ask is like, is there a direct connection to the internet? Does it matter if my device only connects to the internet once every week or 2 weeks?
Yeah.
And as long as the device is spooling that data, it can eventually send it out over the wire. And so like that's kind of the way our smartwatches worked as well. It would connect to the phone sometimes.
No, this is pretty cool. So I mean, the thing that's like, it's kind of interesting for me is once you have those devices and then you have kind of this SDKs, does this change the developer flow, like how you would start developing?
Yes, and so I've talked to a lot of people here actually, and this is I think one of the things that their eyes get really excited. The typical embedded flow is be as safe as possible, develop as slowly as possible, defensive as possible, and like don't use asserts unless you want the device to crash. And try to recover in a lot of situations, right? Don't use the heap.
Without all this, like without operating system having not having the memory management unit is like common sense. Right?
So there's a lot of things there in I believe some of them and I don't believe others. However, I think a lot of that was built during a time, or decided during a time when they didn't have a lot of this diagnostics data. They were like, we need to ship this firmware once, deploy it for 10 years, and that device needs to last 10 years on solar power.
Never
battery.
Change it.
And if it's rebooting constantly or reboots for a little bit and writes debug data, it's going to burn through a flash chip, fail, battery. Anyways, with memfault, I think the flow kind of changes. You have the diagnostic data, and as soon as you get one core dump that tells you exactly how a device hard faulted, you can fix it. Like you can immediately almost know how to fix that crash, which used to take 3 to 6 months for you to reproduce at your desk when it was connected to a JTAG device. But now you crash once, you get it in a few minutes, and you can fix the bug. And so I believe add asserts everywhere. Like add asserts everywhere, make bugs really, really noisy. If the device ever resets, like show it in the UI. Tell the user the device reset, or at least not the user, but like internal testing. And with memfault as well, it's not just in production; it is internal testing. So all of the builds, as soon as you put it on a sealed watch, or as soon as you give it to your CEO to test it, like it should be running some form of memfault or some diagnostics. So as soon as the watch or whatever device crashes in-house, you'll get the information, and it's
excellent. I like this. You are kind of moving this paradigm of like how you would develop in cloud, like microservices, as you said. Like microservices, you start with like really small thing, but you have all the infrastructure with debugging and like we use CloudWatch
Mhm.
to aggregate all these logs and whatever not. And then you kind of have the same mindset that like you should now, with this technology that you enable, have the same kind of development cycle, which like you start small, put all the asserts, whatever,
Yeah.
the barely working thing, and then you would probably see all this crashing, and then you do like over-the-air updates or whatever updates you have in order to kind of iterate faster. And then that is actually, brings me to this point, is what I'm passionate about in general, is like, you're building that infrastructure for fast iterations,
Mhm.
which at the end, the customer benefits, right? You said like, you have a constrained device, you put it there for 10 years, nobody touches it, it does its work. But that means that if you get a new idea, the only way to share this new idea with the customer is to ask them to buy a new device, which is not, good from a customer perspective, right?
Correct. And yeah, I mean, every consumer product, also a lot of industrial products like need firmware update, whether that's
Yes.
for security reasons or because customers demand that they want new features constantly. And especially as honestly hardware vendors go towards subscription model, they're going to expect that there's a firmware update and new features coming along, right?
Yeah, how does that work with the Memfold when it comes to like the over-the-air updates? I mean, like the over-the-air updates, you usually have like a bootloader, which has like a
Mhm.
small amount, like really small footprint, and then you have the application stack on top of this, or if you have the operating system, whatever. But can you integrate the Memfold into like bootloader or like?
It's a good question. What we've seen as a trend from other frameworks and RTOSs and systems, they're building their own bootloader. They're building their own way to firmware update. What people are not providing generally is a good cloud backend to decide which firmware to send that device. Doing the thing that helps you with stage rollout or device
Yes.
configuration
Yes.
or allowing you to jump from firmware to firmware depending on whether it has to go through,
Maybe A/B testing. Or
exactly,
that kind of
A/B
stuff.
testing and jump from 1 to 2 to 3 rather than from 1 to 3. We
Yeah.
had to do that a couple times at previous companies.
Yes.
Like limited flash code
Yes.
space. Anyways,
Yes.
bunch of things. That was the hardest for us to build at previous companies, and it's the thing that we couldn't get cloud engineering resources to build. They didn't believe that it was necessary. They didn't believe that we needed to iterate quickly on firmware. They were like, "You guys are a hardware team. Like,
Yeah.
you're going to ship once and be done with it." So we never got resources to build that, and so that's the thing. We don't provide a bootloader.
I see.
We just provide sort of the ultimate binary that device should install, and honestly, people have systems in place.
Yes.
Yeah.
No, this is pretty cool stuff. I like it. And I mean, coming back to like the development cycle, you usually have a JTAG, you have a GDB,
Mhm.
and then you can step through code. Do you guys plan to have something like that? Is that possible?
Like
to
on locally on my host machine. Honestly, I prefer debugging in Memfold nowadays.
Okay.
Even like we have people who debug locally with their
Yeah.
JTAG device, but you can also capture a Memfold core dump from your
True.
debugger, and so you can capture it through
Oh,
GDB.
right,
We have a
right.
script that you can capture a core dump through GDB, or through a standard debugger, and then upload that to Memfold. Because we
Right.
do some extra analysis that these IDEs
That's cool.
don't do,
That's cool.
and we do some extra parsing. Yeah, it's great, and so people are like constantly uploading it to Memfold.
No, this is really different type of development. At least for me, I mean, I was doing this completely differently, so that's pretty cool to hear. Okay, I think we are kind of running out of time. Anything else you wanted to cover that we didn't cover as of now? I know.
Yeah.
I know that. Your booth is just across ours, so maybe you can also tell us like if you have any demos over there that's kind of interesting. Or
Got it. Great question. So at the Memfold booth, we're kind of showing off the product itself, so you can see the dashboard. We have a few real crashes from real devices.
Okay.
So like they're running either Zephyr or FreeRTOS or ESP IDF. They're real crashes there. And so come over and check that out. And then
I want to see
also
the crashes.
and then the other thing is all of the firmware developers at Memfold generally write for a blog called Interrupt.
Oh.
Interrupt.memfold.com. We believe that before we started Memfold, there was no great resource for learning a lot of these best practices. Like we actually either learned or stumbled across or developed really good best practices at Pebble, and we wanted to share them with the broader world. And so we wrote on Interrupt every month. One of us was required to write a blog post,
Okay.
and mostly every month that blog post would take as many days to write. But we truly thought it was necessary. So thus far it's become kind of a de facto blog for
Excellent.
constrained development and embedded development, and we love it.
No, this kind of like creating this community. I mean, generally, I mean, we talked about this. Like generally, I said the best engineers I met are the ones that are kind of shy and like not on social media and that kind of stuff. But then they have the best ideas, and if you can have the community of those people and then foster it and then kind of make sure that they are aware of this kind of cool technologies, I think it will make this embedded software development much easier.
Yeah, and hopefully the idea of sharing becomes a bit more
Exactly.
popular. I think the embedded space has been dominated by massive corporations
Yes.
and industrial companies and proprietary, and we're trying to do mostly everything in the open. Of course, we have a closed source backend, but our firmware code and all of our learnings are being in the open.
Wow, that's excellent.
Yeah.
Awesome. So anything else you want to add? We have a couple of more minutes.
Got it. I don't think so, but I think if you want to check it out, memfault.com, people can sign up for a trial. They can load it onto pretty much whatever dev board they probably have on their desk. It's pretty easy to connect to our backend, and especially if they have a UART serial, they can just start playing with memfault and see what it feels like. And hopefully the minds get changed a little bit. And yeah, I have a talk at 11:30 on doing exactly this. I would say.
Nice.
Debugging in production on devices.
Oh, yeah.
It's my favorite way to debug. It's also, I would say, the laziest. Like I'd rather let the crashes happen and roll in later, especially during internal testing and stuff like that.
That's pretty cool.
Makes development more fun. It reduces anxiety.
Yes.
Yeah, we've had people come over that are like, the CEO is very scared to push the deploy button, and like our customers have now said it's very easy. They just push it and like go to sleep.
That's really cool to hear. Excellent. Okay, it was a pleasure talking to you.
You too.
It's an amazing thing what you guys built. So looking forward to actually checking out those crashes.
Please come by.
Okay, everybody. Thanks a lot for the session. Talk to you later then. Bye.
Good morning. Thank you for joining us for day 3 here in Embedded World. I am Syed Rehan and I'm a senior developer advocate with the AWS IoT service team. And today I'm super excited because I'm joined by Christopher, who's from Arm. Christopher, tell us
Thank
about
you.
yourself.
Thank you, Syed. Hi, I'm Christopher. I work at Arm and I'm responsible for the microcontroller development tools called Keil MDK. I also look after Semsys, which we will be talking about today. And I'm really happy to be here and have the option to talk to you.
Awesome. So we all know who Arm is, unless we've been living under the rock. So Arm is, it's one of those companies where they are everywhere when it comes to microcontroller. When I heard that, okay, I'm going to be hosting a session with Christopher on board, I didn't know what kind of question I should ask because I was amazed that with the amount of questions I could ask. But in the time frame we have, I thought, you know what, I'll basically ask questions which will be beneficial for you. So let's start. So Christopher, tell us what is exactly Keil Studio Desktop?
We have announced it last week, basically. So it's our next generation tooling,
Okay.
which is based on Microsoft Visual Studio Code.
Okay.
And we provide extensions to VS Code so that developers get a modern development environment that fully supports all flows, development flows that kind of are mandated by Semsys. Especially in this new version, we take a special look at flows enabling CI/CD development because we believe, people are using it right now, but it's more the future of embedded development.
Right.
I think embedded still needs to learn a little bit about that,
Yeah.
but we are ready. We have the tools available that help people to use that with Keil Studio Desktop.
Absolutely. So I couldn't say any better. You said it rightly that the embedded has to do better,
Yeah.
and there are a lot of strides which Arm is doing, and I think Keil Studio is one of the steps in that right direction, right? So you mentioned Keil Studio Desktop, and you also mentioned Semsys. So before I get to Semsys, the elephant in the room, we'll basically talk about Keil Studio Desktop and support of what languages. So what sort of languages will the Keil Studio support?
So we basically support what the underlying compiler which we are using. So you can either use the ARM compiler version 6, or you can also use GCC, for example. And these are C++ compilers.
Yeah.
So basically that's where the embedded world still uses heavily C++, and that's what we're supporting.
Exactly. Awesome. Yeah. C, the godfather of languages, and then obviously C++, which runs everywhere on microcontroller. So let's talk about what is actually Semsys first.
Semsys is an acronym for a very long word. It's the Common Microcontroller Software Interface Standard.
Yeah.
As I said, very long. It's basically an initiative from ARM to standardize on how to use Cortex-M microcontrollers.
Right.
This started more than 10 years ago with a thing called Semsys Core, which was basically a set of APIs that helped you as a developer to access the core peripherals of a Cortex-M microcontroller. And throughout the years expanded rapidly. We have an API for RTOSs, for example. We have a Semsys driver API, which standardizes on things like USB, I2C, Ethernet, and the likes. We have also different other stuff like Semsys DAP, which is basically a firmware for debug probes that our tool or other tools use to access the microcontroller. So it's a big box of chocolates with all kinds of stuff in it.
Big box of chocolate with all the stuff in it. If you want free chocolate, go ahead, head for the arm.com and download it.
Yes.
So, when we were talking, you mentioned something about open Semsys packs. So, for the interest of our viewers out there, let's give us a little bit intro on what is Open Semsys and its relationship with Semsys packs.
Yes. So Semsys from the beginning was always an open source project.
Yeah.
I think it started with MIT license. Today we are on Apache.
Yeah.
But 2-3 years ago, we saw that, mainly the work was done by us. And of course, that takes you only so far.
Yeah,
so
exactly,
we said, okay, let's go more open and put some parts which are very dear to our heart under Linaro. And these are now open governance. And we actually teamed up together with NXP and STMicro to form this Open Semsys Pack group, where we define standards, for example, of software delivery, because the Semsys Pack is basically a zip file. It's not fancy.
Yeah.
With all the, for example, device support, board support, or software components, plus an XML-based description file.
Right.
The magic happens in that description file.
Exactly.
It can be read by tools.
Yeah.
So Keil Studio, for example, but also IAR has an implementation. We have a plugin for Eclipse-based tool chains.
Yeah.
And on websites. So we actually have a big catalog of devices where almost 10,000 Cortex-M devices are now supported by Semsys packs, different software components from various different vendors, like AWS, for example. I think we'll talk about that later.
Yeah, exactly. Yeah.
And in Open Semsys Pack, so this is one of the one part of the initiative. The other is we are now, as I said before, we are trying to concentrate to make CI/CD flows more accessible to the embedded market,
Awesome.
especially by supporting it with CLI tools.
Awesome.
Our old Keil MDK was a GUI,
Yeah.
Windows-based GUI, which is not very good in CLI.
Yeah.
And so we have come up with the Semsys Toolbox, which is a set of CLI-based tools that run on all operating systems, Linux, Windows, macOS, whatever, and you can use that to enable your flows based on a common project format.
That's very exciting because I think you just mentioned that is basically working backwards, as what we say in AWS, is taking the CLI and then building from the CLI output. Right, that's a great idea. So one of the things I usually often get asked from the people I interact with, we have NXP, ST, as you mentioned, right? These are silicon vendors.
Yes.
So for the interest of our viewers out there, Arm actually provides blueprint, and these are the silicon vendors who are actually carry out the implementation of the blueprint.
Correct.
And we need to be, as you mentioned, that you're basically expanding the Open Semsys, or you should say alliance, where you're basically working with silicon vendors such as NXP and ST. Are you trying to standardize the pathway where other silicon vendors can jump on board and say, okay, if you're basically building an ARM blueprint, that we should standardize it so we have a single pathway for success for our embedded and IoT builders out there?
That is correct. So as I said, we started this project with NXP and ST.
Yeah.
They were willing to join us. Any other silicon partner is welcome. And as I said, we have many silicon partners who already support their devices with Semsys packs.
Nice.
As I said, the 10K devices is not only NXP and ST. We have a plethora. I think we have more than 45 vendors, so silicon partners who support their devices by packs. And in the end, we see the need for standardization in the embedded industry because in deeply embedded, so Cortex-M microcontroller class, we don't have something like Linux.
Yeah.
Cortex-A world, Linux, it's Linux.
Yeah.
And Linux says how you have to write a driver, how to access it. That's all crystal clear.
Yeah.
In the Cortex-M world, it's not.
Okay.
And so with this whole Semsys initiative, we try to standardize as much as possible, of course, without taking away the option to differentiate. We totally understand that our silicon partners have different peripherals, different strengths that they, of course, want to show to their end customers. But we try to avoid the unnecessary differentiation.
Awesome. So I know I will ask this question from Christopher later on, because I know our viewers are out there probably itching to ask this question, is that what are the pain points you hear from developers and what are the things you are actually doing? So I know Semsys is one of the steps we mentioned in the right direction. So let's come to that after we have another big elephant in the room, our virtual hardware. Tell me a bit about that. How does it work?
ARM Virtual Hardware is a set of simulation models for the cores. So from the smallest Cortex M0 up until the highest end Cortex M85, plus our neural networking processors, the Ethos U55 and U65. And with these simulation models, you can kind of have a head start by starting to develop your algorithms that you want to run on that CPU and do the simulation and see some outcome. You can start this before you have actual hardware. Or sometimes hardware is not available. I mean, the last 2 years were tough. Right? I mean, not only because of the elephant in the room, but also because there was lots of allocation for the silicon partners. It was hard to get development boards, samples, and whatnot. ARM Virtual Hardware avoids that. It's available in the cloud, for example. We have an AWS AMI available. We also have it on the desktop. So in Keil Studio Desktop, you can simulate on the cores on your local machine. So it's very flexible and there to give you a head start developing your algorithms.
Awesome. Yeah. So, I mean, as you said, rightfully so, in the past few years has been tough. Silicon shortages, stuff like that. However, what ARM has done to move the needle forward for embedded arena or embedded scenario is by providing this ARM Virtual Hardware. I have played with it and I can verify it is awesome. It's for you to get started and obviously start building on it. So if you are C++ developer who's basically thinking about buying plethora of boards out there, why don't you just basically go ahead and prototype using virtual hardware? Right. And obviously it does support C++ and you have plans probably to increase the support for other languages in the future.
This is under discussion. We need to see where the traction goes. I mean, everybody is resource constrained. Our development group is
understood. Of course.
Let me add something. You were asking me in the beginning about Keil Studio Desktop, which is the desktop implementation on the local machine. Actually, we have something that is also very, very nice. It's a cloud-native tool, which is called Keil Studio Cloud. And it's actually the same look and feel, GUI, but it's running in your browser. Completely cloud-native. You don't have to install anything. And this also gives you access to ARM Virtual Hardware. So you can pull in from our website, you can pull in examples that you can then build in your browser on our machines. And you can, for example, connect to the AWS cloud. We have a very nice demo available that is sending MQTT messages to the AWS servers. And it's all virtual, no hardware required.
Awesome. So there we go. AWS and ARM giving you the bootstrap to get started all from your desktop without buying a hardware. So let's talk about what sort of hardware. I know you mentioned few hardware, right? So what hardware is actually supported by ARM Virtual Hardware?
So ARM Virtual Hardware, as I said, it's all Cortex M cores plus the Ethos NPUs. What it also supports is we have a Python wrapper basically, where we have virtual streaming interfaces. So you can stream in and out data. We are not exactly simulating all kinds of peripherals like, let's say, CAN IP or some UARTs or whatever. But with this VSI, it's adaptable because it's Python. So you can also do whatever you like with it. But we are, for example, using it to stream in and out audio data. We have an example available for this keyword spotting, for example. So ML is also big thing what you can do there, because the ML algorithms usually purely run on the core itself, and we're just providing the interfaces to stream in and out the data that you want to test, and then you run the application on the core, and you get your feedback via serial output or whatever, like console where you see, okay, yes detected, no detected, whatever,
Well,
all possible with hardware.
Step by step, we're getting there. We are making life easier for embedded developers. We are opening up the boundaries and borders for you, for trying out new things.
Yes.
So you mentioned SIMSys, right? And I know we talked to offline, but let's talk online and live, and let's talk about AWS SIMSys packs. Tell me.
That's a very cool thing. I mean, this is a thing we started together as a joint effort, I think more than 2 years ago.
Yeah.
You had your AWS CSDK, and
Yeah.
you have FreeRTOS and all that great software.
Yeah.
It was not available in packs. So our teams joined up, and in the end, you created your own packs, which are now in my index.
Yeah.
So every developer can access it very easily. And the big advantage of these AWS packs is that they are, for example, they are versioned.
Yeah.
In Census packs, we mandate for semantic versioning, so
Yeah.
major, minor, or release.
Awesome.
So it's very easy for people to find a specific version, to pin it down. I mean, in embedded, we usually try to use the latest and greatest up until a certain point in time, where
Yeah.
we then say, okay, now we freeze everything. We want to go to production. Let's stop here. We won't take the latest and greatest. We say, okay, I want to use version 1.4.7. That's it. This is again very nice for product lifecycle management.
Awesome. Yeah.
And this is all available through your Census packs. Configuration is very easy. There is in the Census packs you have configuration files. These are pulled kind of out of the pack into the project. You can then do the configuration. They are not attached anymore, and you can version control them, things like that. So that's all. The complete end-to-end workflow for good PLM is available through AWS Census packs.
Awesome. So where can people get this Census pack from?
It's actually hosted on your servers.
Yeah.
Usually the Census pack providers have the stuff under their control. We have an index, and on keil.com/deli2/pack, you find all the packs that are available or known to us.
Yeah.
There are more, of course. You
Yeah.
can also use packs to deliver your software in privacy. You can just send a download link to a customer, or you can send it via email if it's a small pack or whatever.
Yeah.
You don't have to put it out on the internet, but of course, if you want to get access for customers, then it's there. And use the index or use the tools. So in Keil MDK, we have a thing called Pack Installer. IAR Embedded Workbench for ARM has something similar. As I said, Census Eclipse plugin can be used to explore packs.
Yeah.
It's all there.
Awesome. I mean, again, every single thing we're talking about here is basically easing the pain for developers out there, embedded developers out there, for you to basically get started, to bootstrap and get going. I mean, I love the novel idea of this AWS Census packs and how you have actually understood the pain point and worked backwards of making sure version controlling is in place. And you said it, that we have developers out there who are basically saying that, okay, I want to use this version, and they basically go into production with it and whatnot. This is basically something, when I was a developer, I found it very painful, is that by the time I developed it, the project manager came up and said, you know what, we're going to move up a level and we're going to change the version. And we start again.
Exactly.
And this is absolutely brilliant. Keeping that in mind. So I know it was end of the session here, right? I loved talking to you, and I'm sure we can carry on for the rest of the day. But we have to give time to our other colleagues and other colleagues, friends here. So I want to basically ask is that for our viewers out there, our developers out there, our IoT builders who are listening to this, our AWS customers out there, who are basically thinking about getting started with ARM, getting started with AWS, connecting to the cloud, what are the words, suggestion, pain points you would say you can avoid by using things we have talked about, and they can basically have a smooth journey because we wrinkled out the issues?
Yeah. I mean, I would suggest to go to keil.arm.com, our new website, where we host all these example projects that you can use in the cloud version of Keil Studio. So if you are in kind of the discovery phase and you want to look for a new device or for a new piece of software, go to keil.arm.com, import an example project into a Keil Studio Cloud, run it on virtual hardware, or here comes the catch, or we're using web USB technology you actually can plug your development board into your PC and via the web browser get the connection to the PC, so you can also run it on real hardware.
Awesome.
If you're lucky enough to have a dev board from your favorite silicon partner,
Yeah.
then you can also run it on there and give it a try.
That's pretty awesome. I mean, I've learned something, that, using the web USB, I'd love to try that. I mean, once I get back to London, I'm going to be hitting that desktop and trying it out. So with that, we're coming towards end of time. The links which Christopher has talked about, we'll basically post it on our description or the link on the comment section. If you have any questions, reach out to us. We can always get back answers for you from Christopher offline. But thank you very much, Christopher. It has been an absolute pleasure having you on the session here. And, I really enjoyed it. I'm sure our viewers out there enjoyed it. It has been, superb. Time just flew. So thank you very much, Christopher.
Syed, it was my pleasure.
Yeah.
Thanks for having me, and have a great rest of the day.
Yeah, exactly. And enjoy the embedded world. If you're here, go and harass Christopher.
Yeah, I'm at the ARM booth.
Yes,
Here in
he is at
Hong
the
Kong.
ARM booth. Yeah,
Yeah.
there you go.
Thank you.
Thank you. Watch out for the next session, and we'll be back.
Hello and welcome back to IoT Builders live from Embedded World. We are in Nürnberg, Germany, and we're in the AWS booth in Hall 4, booth 550 in Hall 4. And my name is Dan Gross, and I'm a senior developer advocate with AWS, and I am joined today by Martino and Carmelo, both from Telit Cinterion. Hi, guys.
Hi.
Hello, everybody. Hi. Hi, Daniel. Hi.
So on this session today, we're going to talk about building awesome AWS IoT ExpressLink products with Telit Cinterion. So, hey, why don't we start with some introductions? Maybe tell us a little bit about yourselves and your title and what you do at Telit Cinterion, and yeah, maybe we'll go from there. You want to start?
I can start first.
Yeah.
So, Martino Turcato, I'm head of software with product management team and Telit Cinterion. I'm basically the guy that look after all the value-add software and the integrated services for our module, wireless modules and positioning modules. I also take care of security and developer enablement.
Yes. So I'm Carmelo D'Agostino. I'm product manager in Telit Cinterion for Wi-Fi and the Bluetooth family of modules. So basically, I help to define the strategy and the roadmap for this family of products, taking account of market needs and feedback from customer and inputs from the market in general.
Okay, great. That sounds fantastic. So first things first, Telit Cinterion. That's a new name.
Yeah.
And I think it's a result of an acquisition that you made.
Yeah.
Maybe you could tell us a little bit more about that.
Actually, we just announced the rebranding because we used to be Telit, now Telit Cinterion, because we have acquired the IoT division from Thales, which was Cinterion.
Yeah.
Now we have rebranded the company into Telit Cinterion, and we basically strengthened our position in the market because we brought together the experience of two leaders and pioneers in this market, and so let's say enlarging our footprint, our portfolio, and providing better solutions to our customers and more value. We are effectively now the Western leaders in our space, and if you look at what's going on in the market with the more consolidation happening, we are really in a good spot now, and also with some key players that are stepping back or discontinuing their solutions. I think there are more opportunities for us.
Yeah. Well, that's amazing. Yeah, that's really amazing. I know that kind of surprised some people to hear that, and it sounds like a really great partnership and acquisition.
Yeah, absolutely.
Oh, that's fantastic.
It makes a lot of sense.
Cool. So I see you have a toy there, but we'll get to that in a minute.
Yeah.
First of all, let's talk about the IoT ecosystem. Like, what do you see happening in the IoT ecosystem today? You're involved in it. What kinds of trends are you seeing, and general points do you think are interesting about IoT right now?
Yeah, look, I think we already mentioned this consolidation that is happening. Also, what we see is some of the trends and best practices are becoming now mainstream. So, for example, with the AWS ExpressLink, what we saw, when we first saw the concept, it really resonated because that we saw that we came to similar conclusions or approach to solve similar problems. Let's say from different paths, but then it was easy for us to embrace the initiative because we already had all the building blocks and the processes in place to do that because we already were implementing it or using for our products. So that was really, let's say, an easy integration with your ecosystem. So
I see.
That's the good side of it because it's a sign of maturity. Let's say, trying to reduce the fragmentation, try to have a common approach to similar problems, and let's say bring into the mainstream some of the solutions that only a few years ago were kind of on the edge or not, let's say, well accepted by the ecosystem.
Yeah. And you're referring to AWS IoT ExpressLink, which we've been hearing as a theme at Embedded World. There's a lot going on. We're here at the AWS booth, and we can see just from where we're sitting a number of demos and different things going on that relate to ExpressLink, and so that's really great that you're finding an alignment with that with what you're doing. I think what makes that easier for developers and basically product builders is that the amount of time it takes to develop some of this software and even hardware design, can get quite lengthy, and ExpressLink really kind of reduces that down by encapsulating that into a single module and really offloading a lot of that burden from product developers, right?
Yeah. It's all about time to market and also bringing more simplicity into something that is not so easy, especially cellular connectivity is not simple if you are naive. And also, security is another important aspect.
Right.
Frictionless onboarding. These are all the concepts that really make this product something that can reduce the time to market, but also enable scalability, because that's the other side of the coin. If you do it right, it's easier to implement, but it's also easy to scale, because coming up with a POC may be easy for most of the developers, but then scaling up, if you haven't implemented right, it's near impossible. So do it right from the beginning, let's say.
Yeah, because then it becomes repeatable.
Yes.
And what you need is something that you can trust, that's repeatable in order to scale, right?
Yeah.
If you put your pieces right at the right place at the beginning, then it's easier than when you grow and needs more resources. So getting started on the right path at the beginning, I think it's really essential for a proper scaling of development and the success of the solution.
Yeah, that makes sense. Okay, so do you want to talk a little bit about let's see, the module that we've heard about, and the toy that you brought along here? Maybe we can show.
We're actually announcing two products. One is the module, the Alina Intensive one for ExpressLink, which is a Cat 1 module, the first Cat 1 module joining the ExpressLink family, and this is important because we're filling an important gap there. And the second is the Bravo board, which is this toy here, which is a development kit, but it's I prefer to call it a rapid prototyping tool.
Okay.
Because it comes, of course, it includes the Alina Intensive one, but it also brings lots of good stuff with the module. Some cool sensors from Bosch. We can provide more details if you want later. Connections to the most popular development boards like Raspberry Pi Zero, Arduino, digital IOs, and another cool stuff is the fact that we bring into the same board also the microbus. So this can be virtually expanded to any sensor or peripheral that you need. So it's an all-in-one. Really. You can really do a POC or even a proof of product just by using what is sitting on this nice board and by using your Raspberry Pi or Arduino.
Yeah, so this is the Bravo board. It's what you're calling the Bravo board. We'll just put it up to the camera here to see it. But this is breaking news here. So this is really great to see. And then this is the module here, the silicon right there. And that is the LE910C1, is that right?
LE910C1 WW. WW stands for worldwide.
Yeah.
Because this is a global SKU.
Okay.
So basically, you have
an important point.
You have all the bands and the frequency to go anywhere in the world.
Yep.
Actually, Cat 1 is still the best technology if you really want to achieve worldwide coverage, because it's more mature and it's basically provided anywhere in the world, in whatever country you need to deploy your solution. And also, it's much easier to provide data plans that can really, be used across the different regions. And it's going to be a very, longevity is not an issue, because operators are, will provide access to this technology for the next decade and probably beyond. So it's, if you're really looking for worldwide coverage, this is still the best option.
That's really great.
So it's important. And the other important aspect is that this is mid-speed, what we position as a mid-speed technology.
And what does that mean?
So, that means that you have more bandwidth, you have a faster link to the network. The uplink can reach 5 megabits per second, and the downlink 10 megabits. So this is much closer to, let's say, to more powerful devices that are, maybe based on Wi-Fi.
Yeah, exactly. Yeah, I mean, this is something that is will bring values because it differentiates compared to other modules that are already part of the ExpressLink family.
Yeah.
So this is cellular connectivity, worldwide coverage, better bandwidth, lower latency. So all things that are new and can bring really value to customers.
Yeah.
Just to add a few things on the module itself, it also has concurrent GNSS, so it supports a quad constellation. So this optimized for tracking assets, and we can see there are lots of our customers that are already using these modules have a lot of application. And,
that's a really important use
very
case, and
flexible,
especially
yes.
for Cat 1. That for example is a very suitable use case, because you don't know if you're going to have Wi-Fi as the assets move around potentially, right?
Think about asset tracking.
Yeah.
This is a use case where Cat 1 is already pretty successful.
Yeah.
Especially if you have to send frequently your position, or you have large payloads because you need to report, let's say, lots of data points about the state of your asset. Well, that's a perfect fit.
Yeah, I mean, imagine even being here in embedded world and moving some assets around the different halls. It would be challenging without something like that, right?
Yes. Another use case example is, for example, metering. So it's cellular technology is complementary to Wi-Fi technology. So you can we have the customer that are employing both technology in the metering solution, and they have different situations where they need either Wi-Fi, either cellular connectivity. So this is something that really expand what customer and can do with this kind of producing products.
Yeah. Let's talk about some other use cases on top of asset tracking and things like that. What other areas do you see this solution being suitable for?
Yeah, another example could be smart cities, for example, smart street lighting or home security application also. So there are, the fantasy, the sky's the limit for this kind of products. Yes, they are very flexible. And so one that I would like to mention also, we touched this briefly, is security aspect.
Of course, yeah.
Yeah, security now it's keyword in our world, and everyone is concerned about security.
Yep.
So this module is based on Arm technology, so it includes all technology that Arm provide in their platform. So I can mention Trustdome, of course, based on Arm, Secure Enclave. We have the key, so trusted execution environment. So all features that make this module very useful, very performant in this situation where security is a key element of the solution.
Yeah, that's really important. So not only it's really security at various layers too, because it's on the chip, but it's also with ExpressLink, it's sort of built-in security as well, right?
It's important. It's really important that we have such a secure subsystem available in the module, because all the critical operations, of course, the secure storage for all the secrets and keys.
Yeah.
But also the critical operations of signing or let's say setting up the initial handshake of the TLS.
All of the provisioning.
Everything is executed inside the secure world of the secure enclave, and this is how we increase the security level of the implementation. So there are some very good guidelines and requirements about security in ExpressLink, and this is a perfect marriage with such a platform, because you have all the building blocks that you need to have in place in order to really walk the talk on security.
And having some of these features available is a little bit different than having them implemented, right? And so with something like this, you not only have these security features available, but they're in fact already implemented too, because with pre-provisioned keys and certificates,
right?
You can literally connect to the cloud right out of the box, right?
Yeah, and that's important because the customer can really offload all, the operational burden in doing that, but also offload the risk, because basically the customer doesn't need to deal with any secret. Everything is already inside. The onboarding is automatic, so they get the certificates in their IoT core instance, and then the thing is there. They just need to connect. And send data.
First, use the AT command set in order to get started. So, how do you get started on this board? Is there? You mentioned you could use Arduino or Raspberry Pi or other things. do you have any recommendations on
Well,
getting
that's
started?
the simplest way.
Yeah.
Choose the ecosystem you prefer, just
Yeah.
plug it in, and then you're good. But you also have the serial connection. So if you have an external
Right.
MCU and you want to do something fancier, just connect to the serial port and send the AT commands, and then you're good to go.
Yeah. So you can
Uh,
interact with the board directly, or you can do it programmatically through the
Yeah,
interfaces.
actually
That's great.
today-
Yeah.
Today it's an ExpressLink discussion, but this board with a different software, because we have other things that we are working on with
Yeah.
you guys. For example, this board could become a standalone one and
Oh.
have IoT core running because we have the application processor, the
Yeah.
IoT core SDK running on top of the application processor. So basically, you can connect directly to the sensors, for example,
Yes.
and then run your application from within the module.
Oh wow.
But that's a different, let's say, use case.
Yeah.
With ExpressLink, in order to keep it really simple, you connect it to the serial connection and
Yeah.
then send the AT commands.
And then you're off
and
to the
it's a
races.
simplified set.
Yeah.
Nothing has nothing to do with, let's say, with the classic set of AT commands that people are used to deal with. So it's all about simplicity. And also the demo we created. If you go to our booth, you will be able to see it in action. But also you can go to our GitHub and Telit GitHub, and then you can see how simple it is to really connect and send data. It's just you can find a Python script. It's just a bunch of AT commands, and then you're good to go.
Yeah.
I mentioned that on our website we have a landing page for this development board. So if you
Okay.
go-
And where is that? What
It's
website?
www.telit.com/Bravo. So there you can find all the information, download all the.
Yeah. So when a developer is getting started with a board like this, how do they work with the cellular aspect of it? Do you need to get a SIM card? Do you need to, is there anything special you need to do with that?
Well, thanks for bringing this up because Telit Cinterion actually we provide products that are let's say that are covering several areas of the value chain because we
Yeah.
provide the wireless modules, but we also provide connectivity
Yeah.
with SIMs and data plans, but also and connectivity services.
Yeah.
We also offer software for the edge and the cloud, whether for constrained IoT devices or for industrial applications and
Yeah.
platform. So all the tools that you need to design, to simplify the design, the deployment, and the management of IoT. Actually, I would like to mention also that through the recent acquisition of Mobilogics, we can also now offer ODM services. So basically, we are really more into the solutions now.
Yeah.
And yes, that's
great. Yeah.
Yeah.
So it really gives you a variety of options to
and
get
so-
started. Yeah.
And so basically, this board comes with a SIM,
Yeah.
with some prepaid
Yeah.
data plan
Yep.
that you can use out of the box, and it's our connectivity offering,
Yep.
which we were talking about a worldwide SKU.
Yep.
It's a worldwide SKU also for the SIM, so you're really good to go.
That's
You should
perfect.
have almost everything you need to really create your product.
Yeah. Yeah.
Just a few words. So this is our first product that's coming in the AWS Express ecosystem, but we are going to continue this partnership, and there are new products that will come soon in the Wi-Fi Bluetooth technology that will announce soon as part of the AWS ExpressLink and AWS Core ecosystem.
Yeah. Well, that's really exciting. So this is just the beginning, is what you're
Yeah,
saying.
it's just the beginning. The Alina Intensive One will be on the catalog in the next few days. The Bravo board will be available for pre-orders in the coming weeks. So
okay.
go to the page,
Yeah.
then you can subscribe and get the latest updates. And then when it becomes available for pre-orders, you will be notified. And the board should be available for production in the June timeframe.
Okay.
So
all right.
they are almost there.
Yeah. Yeah. Okay.
And,
So keep an eye out for that.
Yes.
But this has been really cool. So the module is the LE910C1, and the Bravo and the board is the Bravo board. So this is fantastic. Well, thanks a lot for taking the time and sharing this with us. Really appreciate it. It's been great talking with you.
Likewise.
Yeah.
Thank you.
If you got anything else going on at Embedded World?
Yes, please come visit our stand. We are here and we are eager to to meet you.
Okay,
There's
yeah.
a few hours left, so come find us.
Yeah. There's just a little bit of time left, so yeah, come visit Telit Cinterion and AWS. Thanks a lot for joining us on this session. We've got more sessions coming up today, so stay tuned. Hello, welcome back. My name is Dan Gross. I'm a senior developer advocate for AWS, and this is IoT Builders live from Embedded World in Nürnberg, Germany. We're currently at the AWS booth in Hall 4. This is booth 550, and I am joined today by Rick O'Connor, who is the CEO of the Open Hardware Group. Hi, Rick.
Hey, Dan. Thanks for having me.
Absolutely, absolutely. So we're going to talk today in this session about FreeRTOS and the Open Hardware Group and the Core 5 MCU Dev Kit. So Rick, maybe tell us a little bit about your role and what you do at the Open Hardware Group.
Sure. So the Open Hardware Group is an open ecosystem developing open source hardware.
Okay.
So we've learned lots over the years, 20 years of success of open source software. Why can't we have open source hardware? And the IP that can be integrated into SoCs and used in high volume production and deep submicron nodes that you can trust and commercialize and share in a public domain environment.
That sounds awesome. That sounds really awesome. And I know that we've been working together, AWS and the Open Hardware Group. But before we get into all that, let's talk a little bit about why the Open Hardware Group, and maybe even further back, what is RISC-V?
Okay, sure. Yeah. So RISC-V, RISC-V that some people say, and of course that's incorrect.
Oh, okay.
Because it's Roman numeral 5 is the V.
Okay.
Is an open instruction set architecture that came out of the labs at UC Berkeley. Dave Patterson, basically Patterson and Hennessy worked at Stanford, but Dave Patterson is credited with coining the term RISC.
Okay.
30 years ago almost now, right?
Yeah.
And the 5 stands for the 5th generation of RISC architecture research in that lab at Berkeley.
Yeah.
And this 5th generation started work in 2010.
Okay.
2011 timeframe.
Okay, so this is at least 12, 13 years or something.
Yeah. And so that was under the leadership of Dave Patterson and Krista Sanovich. And they wanted to have, sort of a clean slate ISA that they could use for next generation pedagogical purposes, right?
Okay.
In their teaching curriculum and research curriculum. So they started working on the ISA, and quickly realized after multiple paper publications and a little bit of attention to the industry that, hey, this was a project that needed to exist outside the four walls of Berkeley because it started to get some interest in adoption or curiosity, at least back then, from industry. So I started hanging out with Dave and Krista, sort of late 2013, 2014 kind of time frame. And we started the RISC-V Foundation I think we incorporated in the nonprofit in the U.S. in August of 2015.
Oh, wow. So that was your doing.
Oh, I was just there and happy to be, along for the ride, if you will. But yeah, so I ran that organization. There was, I think, around 20 or 30 companies that we had at the time.
Wow.
That helped start it.
Yeah.
Define the governance framework. How we collaborate on the ISA spec and so on. Ran that organization for 4 or 5 years. Grew it to 250, 300 companies.
Yeah.
And then left to start the Open Hardware Group.
Oh, wow. Okay, so yeah, thanks for the history lesson there. I think that's really valuable to understand. How we, how RISC-V really came to be, and the instruction, the need for a new instruction set, right? That kind of thing. So yeah, let's now talk a little bit about the Open Hardware Group and the genesis of that, and maybe what's different about the Open Hardware Group than the RISC-V Foundation, for example.
Yeah, it's a good question. We get that a lot. And when I had my RISC-V Foundation hat on, part of my role was to evangelize the ISA, events like this, talks, travel the world and say, RISC-V is good for you. You should take a peek, kind of thing. Lots of benefits and features, and encourage adoption and as many implementations as we could possibly encourage. Right?
I see. Yeah.
Because it's an open spec, the barrier of adoption is zero. Right? You and I could
Download it.
download the spec, hang out in your kitchen for half a day, and bang out a core and start a business if that's what we wanted to do, or implement it into our own ASICs or whatever we were into, right? So,
Yeah.
And the role is very much about encouraging adoption and making that easy, which is a great thing.
Yeah.
And in that context, I love all my children, right? All implementations are good, and the more the merrier. The big ones, the small ones, all shapes and sizes, and everything's great.
Can't pick a favorite, right?
No, love them all.
Yeah.
Rightfully so.
And that's good. And RISC-V is continuing on.
Oh,
with
very
that,
much so.
With that,
It's very healthy. It's continues to grow. The foundation's doing a great job. There's lots of adoption.
Yeah.
There's lots of volume in terms of cores shipped, regardless of where those cores came from. Whether they're open, proprietary, what languages they were written in.
Yeah.
And one group out of ETH Zurich, with the Benini's team, had been doing RISC-V, or low power architecture research for a while. They had their own processors that they were using, but then adopted the ISA because it's a good thing to do.
Yeah.
And started developing and releasing into the open source domain well-written system Verilog based cores, and started to get attention from some of the big guys like NXP and Silicon Labs and so on.
Yeah.
So there was a catalyst, if you will, or an interest, and we like these cores.
Yeah, we'd like to keep these cores going. Yeah.
Yeah, let's build an ecosystem around them. Verify them to commercial standards, if you will. So if you worked at an SoC company, that you can be confident. Walk into your boss's office and throw your badge down on his desk or her desk and say, "Hey, boss, I met my badge that we can use this core from a repo that we found online and put it into our next, $100 million development or whatever SoC."
Yeah.
And be confident in doing that.
Yeah.
So that's what the ecosystem's about.
Okay.
And how we got started.
Okay, well, that's perfect. Yeah, that's really great. So let's talk a little bit about the core development itself. How would you characterize the Core 5 MCU?
Core 5 MCU is really a platform that we can showcase the quality of a 4-stage CVE 4 is in the family name, the Core 5 core.
Yeah.
It's a 32-bit 4-stage embedded class core that's integrated into the MCU. It's fully verified. All the verification coverage reports are available online.
Yeah.
And this is a means of integrating it into really a vanilla flavored MCU. We're not doing, we're not solving world hunger or anything with this MCU.
Yeah.
Building it in 22FDX with Global Foundries, a member and strong partner in the OpenHW ecosystem. Putting it on platforms, connecting it into interesting infrastructure like ExpressLink, which we'll talk about.
Yeah.
And running interesting OSs like FreeRTOS, and have a platform that we get into the developer community.
Okay.
Because when you think about the OpenHW ecosystem, we're really an IP vendor.
Yeah.
So the projects that we have in this ecosystem need to replicate all of the deliverables that you would expect to see from an IP vendor.
I see.
And open source lets SoC integrators, gives them another option. From the standpoint, they can make their own. So the NXPs of the world certainly have the chops and Scilabs and so on to develop their own core, do the whole thing themselves, maintain it themselves, own it themselves, integrate it.
Yeah.
Or go out and license one from a commercial vendor, which they do all the time, Arm and other RISC-V vendors for that matter, which is great. Or have a third option. It's in the middle. Open source, where there's some development attached to it because you should engage in the projects. There's obviously costs that they will bear in order to do that, but it's a royalty-free, permissively licensed open source implementation.
Okay, so that's interesting. You mentioned Global Foundries, and where the chips are being manufactured, but you're not really in. This effort isn't about selling chips. It's about enabling others to make chips essentially.
Exactly. So with Global, the relationship that we have with them, and it's excellent. We love Global Foundries.
Yeah.
They let us build in 22FDX or 12LP, you're right, it's not a production SoC from the standpoint that there was no part number. You can't go buy this from NXP or Silicon Labs today.
Yeah.
It's a device that will only be available on dev kits.
Okay.
That we will manufacture, distribute through DigiKey, and sell on a cost recovery basis to enable the development community.
I see.
If you like this MCU and you want it exactly as is, or you want to take it and modify it, it's all open source. Go get it. Go do your deal. If you want to leave it at Global, you can do that. If you want to move it to another foundry, you can do that.
Yeah.
But go do your deal with Global, get your own mask set, and away you go.
I see.
And take it off the production.
Yeah, that makes sense. So really, it's like a reference implementation of the chip.
But we're trying to bring a little more, if you will, credibility to the term, from the standpoint that it's not intended to be a prototype. It's not a fully production proven device. That's true. But it's quite way down the path to enabling you to get there.
Yeah, not much missing at that point. Yeah.
Maybe only whatever secret sauce you want to add.
Yeah. So that's fantastic. Okay, cool. So you mentioned a couple of members to Open Hardware Group in there. You have quite a membership with Open Hardware Group. I know AWS has joined the Open Hardware Group.
We certainly have. Thank you very much.
Yeah. It wasn't me, but yes, you're welcome.
Just say thank you. Yeah, you're welcome. Yeah, so we have 100 plus members and partners in the ecosystem. We have, I think, 23 active projects. There's 9 different cores in the Core 5 family.
Oh wow! Okay.
From very small 2-stage embedded class cores, 4-stage cores, multiple of them, a whole variety of variants on a 64-bit architecture, Linux capable architecture.
Oh wow! Yeah.
For application class cores, vector accelerators attached to the cores. Quite a range of projects that are underway.
Yeah.
And it's a very, very healthy ecosystem. And like I said earlier, you should think about the ecosystem as providing everything that someone would need to evaluate IP in a commercial IP setting.
I see.
So all dev kits, software, OS porting, GCC, LLVM, compiler tools.
Yeah, I noticed a lot of the members. It's quite a spectrum. You have people that are focused on tooling, others focused on different aspects of that whole spectrum.
It's the whole ecosystem.
Yeah,
right? And it's an enablement aspect. And the great thing about doing this in open source from a hardware standpoint is there's no three-way NDAs, there's no lawyers involved. Everybody just pick the stuff up, start playing with it. You don't have to be a member to use any of this stuff. It's all permissively licensed.
Yeah.
Obviously, if no one's a member, then there's no ecosystem. So there's a trade-off there. And the reason that companies join is because it's the members who decide what the projects are. So building this dev kit was a member-driven project.
I see. Yeah.
So they the members define the project, contribute the development engineers to it. So your guys work on this project.
Yeah.
And define the requirements and the priorities associated with the project and execute it.
Okay. Yeah. That's great. Let's talk a little bit about what we've got here. We brought a toy, or you brought a toy, and
you have some of these toys too.
Yeah, that's right. But this, so maybe talk about what this is. I'll just show it for a little bit to the viewers.
Sure. So this is which is typical with pretty much all processor IP development. Any development would use hardware emulation, FPGA-based hardware emulation as part of the validation of the design.
Yep.
And also as an early software development platform that you can get a head start on the software development before real silicon shows up.
Right.
So this is Digilent is a partner of Open Hardware, and this is a Nexus A7 board that has the Core 5 MCU RTL synthesized into it. We've got a little daughter card or mezzanine card or whatever you want to call it. Bolted on top of here because there's no Wi-Fi connectivity on this baseboard. But even if there was, we'd want to have a daughter card anyway because we have a special Wi-Fi radio on here that implements ExpressLink, right?
That's fantastic.
To connect into AWS Cloud.
So that makes it super easy because you really don't need to implement much in terms of a connectivity stack. It's all self-contained. It's right there. It
You don't
just
need
works.
to implement anything. I mean, this is an authenticated endpoint that connects directly to AWS cloud. AT commands, UART-based AT commands off to the radio, and
Yeah.
boom, you're connected.
Yeah,
So we have
fantastic.
a demo actually running here at Embedded World. The weather station fleet demo that we've used before.
Yeah,
So
yeah.
we've got a bunch of these things spread around the world, streaming local temperature.
Yeah.
It's not technically brilliant. We haven't, done anything magical with the actual technology, but the whole point is this is an open source stack
Yeah.
at the software level right down into gates.
Yeah, and you have a dashboard for that, and you could see all the different temperatures, and it was fairly easy to implement, honestly.
Yeah, it was. I mean, your guys helped out a lot from the standpoint that, how to get this into an AWS database and Grafana dashboards and all that good stuff. But it's a pretty cool example of what you can do with a, industry grade open source platform.
That's awesome. So, so where are you going from here? I think there's a dev kit in the works. That's the actual silicon, right?
So the silicon is going to fab first half here this year.
Okay. Yeah.
We'll have real hardware boards back in the second half.
Okay.
And like I said, those would be we can supply up to 10,000 of those.
Yeah.
So we're going to be releasing those on a cost recovery basis. A company called Group Gets is managing the manufacturing of those.
Okay.
It was a member, and we'll be once they're out, we'll do hackathons and have all kinds of different design competitions and that kind of stuff. We'll probably be able to do something together at that stage.
That'd be great.
That'd be good.
Yeah.
And again, it's all FreeRTOS based in terms of the OS, and
Oh yeah, that's an important.
Connect.
Yeah, that's an important point. Is so you can write your applications with FreeRTOS and on the host MCU, and then actually use. And will ExpressLink be on the dev kit?
Oh yeah, absolutely. So this is this Wi-Fi radio is from Espressif.
Okay.
Right?
Yeah.
And so this is also a RISC-V based core.
Ah yes, the
Right.
C3, right?
I think so. Yeah.
Yeah.
So this is their core. It's a proprietary core, which is great. It's fine, but it's just another example of using RISC-V.
Yeah.
And for sure, that's going to be down on the dev kit board when we manufacture it.
Great. I'm really looking forward to that dev kit board. I think it'll be
So are we.
fun to try and write more FreeRTOS applications to it on RISC-V, which FreeRTOS supports.
Exactly.
So yeah, it's all great. Okay, I know we only have a little bit of time left. Anything else for our viewers and listeners about Embedded World? What Open Hardware Group is doing, and anything
So we're just around the corner from you guys over here at 455, I guess, is our booth number.
Okay.
And it's super easy to get this stuff if you want to go play with it yourself.
Yep.
It's all open source. You can download the bitstream. We have weekly builds of the bitstream available that are uploaded onto our AWS servers.
Okay.
Thank you very much. That folks can download if they have this board already and get started and start playing.
Okay, awesome. Well, yeah, it's been a real pleasure, Rick, for having you here. Really appreciate you taking the time.
Oh, thank you, Dan.
Yeah, great. And we have more sessions coming up on our live stream, so please stay tuned. Again, this is IoT Builders. We're live from Embedded World in Nürnberg, Germany, and we'll talk to you in a little bit in the next session. Bye.
morning, afternoon, wherever you are watching us this session. So I'm back with another ARM guest here with me, and this time I am joined by Parag. So quickly before I hand over for Parag's introduction, if you might have seen me before, I'm Syed Rehan. I'm a senior developer advocate with the AWS IoT service team. So without further ado, Parag, please tell us about yourself.
Sure, I'm Parag. I run segment marketing within ARM. What segment marketing means is we look at the broader IoT markets and kind of divide it up into segments where we have to focus on. So I take care of making sure the products are correct, talk to customers, talk to partners, and making sure we are winning the segment from a business point of view.
Awesome. So, in this session, what are we going to talk about? I mean, I know the session is about smart camera software framework, right? Tell us what the viewers they should look forward to in this session, where you're going to entice them.
Yeah, so I think if you look at it much broader, smart cameras are going through a phase of transition, right?
Yeah.
Where there were, I think it's estimated that there are 1 billion cameras already installed.
Yeah.
And machine learning, imaging, compute, security, all are becoming more and more important because cameras are really capturing everything live.
Yeah.
So when these vectors are really changing the cameras, what we wanted to talk about today is how do you enable the software paradigm shift to make sure these smart cameras are really deployed. So this is what we'll kind of focus on today. So when we say software framework, what we mean is MLOps, DevOps, even how do you make security updates. So it's more about the software framework or paradigm shift that we're going to talk about in deploying future smart cameras.
Awesome. So, I mean, as you said, rightfully so, right? In every developer's pain points we see is that CI/CD pipeline. You build it. What do you do with it? You know, you got to take the deployment pipeline and get it to the end product. Especially when we're talking about embedded products, you got to take it there. I mean, building a web application is easy. You just deploy it, it goes to the cloud, right? Whereas building it on an embedded environment, you know, we will shortly get into virtual hardware. We'll also get into a web USB. I had a discussion earlier, and you know, we will get into that. So let's first talk about how is machine learning deployed on smart cameras today from our perspective.
So remember I talked about the 1 billion devices that are already there deployed in the world.
Yeah.
So currently machine learning is deployed on running on the CPUs on these deployed cameras.
Yeah.
But moving forward, what we see is a lot of silicon partners are adding custom machine learning accelerators.
Right.
So that it can detect that your cat is roaming around, or you have a package, or even false positives, like if the leaf is moving and it sent you a trigger. So machine learning is really becoming a lot more important, and it's connecting to personal lives.
Yeah.
So that's what's happening on, I would say, the smart home camera side. But if you look at much larger cameras, like let's say the cameras in this conference, it's actually counting the number of people that are passing by a certain point. It's all being done on machine learning, and then these cameras are all connected together too. So you can see that it's trying to do heat maps of where there are areas where there's a lot of focus. Is AWS booth the most famous one? Something like that, right? So I think that the use of machine learning is really growing in camera. So these are just some examples that I gave. Now, with respect to deployments, what we see is there's a new business model being deployed. Like we call it video surveillance as a service. If you have Ring cameras, some of the consumers are paying, say, $2.99 or $3.99 so that you can detect packages. But it's a business model change that's happening where once the cameras are deployed, based on the services that you need, the OEMs can deploy newer models. So license plate recognition, heat map generators. So it's a paradigm shift. That's the main topic that we want to talk about today.
Awesome. Yeah, I mean, the world is basically becoming, it's more of a see and tell,
Yeah.
you know, and that's what exactly what you mentioned. And having these ML accelerators on these camera devices will actually pinpoint exactly what's actually happening in our daily lives. You know, as you mentioned, Ring. I'm an avid user of Ring, and you know, I have cameras all around my house. My wife basically tells me that the notification went off, and this is where I realized that okay, being the man of the house, I gotta go and basically watch out, you know, what's happening. And more often than not, it's a cat or a dog, right? And this is where, you know, having this differentiation is really good. This is a great point you mentioned. So tell me a little bit about this pain point which you have seen about these ML accelerators getting deployed on these devices. Where you have, I'm sure, you know, being Arm, you have worked with loads of silicon vendors.
Correct.
What are the challenges you're seeing? What are the pain points you're seeing? What are the feedbacks you're receiving?
So let's start with the pain points first, right? So it's very tough for many silicon companies to start how much acceleration do I need?
Yeah.
Because the more you add, the cost increases, and maybe you added more than what you need.
Yeah.
That's one problem.
Yeah.
The other thing is if you add less, then you may not be competing properly with your competition, right?
Yeah.
So I think at the physical hardware level, that's what is going on. I think, but we see clear sub-segmentation happening where, like example we talked about, conference hall cameras. We know how many TOPS requirements there are, and we also know for smart home cameras like the Ring cameras what the TOPS requirements are. So I think the hardware stuff is settling, but I think on the software stuff, it's a completely different ballgame.
Yeah.
What we see is a lot of silicon companies, machine learning is new to them.
Yeah.
So that's where we partner with, we actually recommend partnerships with AWS because you have SageMaker and many other tools where you have your data sets, you train your models based on the use case, and then you also provide services to deploy them onto these cameras, right?
Right.
So what we try to do is provide these examples, like you talked about virtual hardware, so that if you're a developer, MLOps becomes part of your flow and you don't need physical hardware. So we're trying to look at it from a developer point of view and see, okay, what do they need and what services can they use from AWS so that you take this as an example and then you figure out how to deploy it in a much higher volume.
Awesome, awesome. So you mentioned a couple of nuggets there.
Yeah.
I want to basically go and bite those nuggets. Basically, we talked about you know, Amazon Reputation, Amazon SageMaker. So obviously, you know, we work very closely with Arm when it comes to ML inference because obviously we have Amazon stores where you know, which are cashierless store. You just walk in and walk out. This is where thousands and thousands of cameras basically taking care of what you have picked up and whatnot. So the world is definitely heading in that direction. Definitely in that direction. You talked about AVH, Arm Virtual Hardware. You talked about developer pain points. I mean, I had Christopher earlier where we had our geeks on when it comes to Arm Virtual Hardware. So I'm going to basically bite the nugget and I want to talk about, you know, AVH and how we're basically seeing AVH pathway into basically this camera ML ops journey.
I think to start off with, we do see Arm Virtual Hardware as a huge enabler for developers. So we have a AVH, what we call the board model for an NXP device.
Yeah.
And we model quite a few number of elements of that.
Yeah.
And what we have already showcased is we took your services like AWS Greengrass, SageMaker, all running on AVH through a full CI/CD pipeline.
Awesome.
So that if you're again a OEM who is looking to figure out, okay, how do I deploy my models and all, they don't even need to buy the hardware. They can just use the AVH.
Yeah.
We work with Dave Walters of AWS, who has a great example blog of how to do this.
Yeah.
So it's a great starting point. So we are really using AVH to showcase many of AWS services so that they can easily get started. They figure out the flow, how to deploy everything, and then they can buy the hardware and deploy. So it's really a developer enabler. And we've already showcased it on NXP platforms. We have Raspberry Pi.
and we are going to add more and more platforms to our AVH library.
Awesome. So a little bit digging on that one. You mentioned NXP. So
Yeah.
which hardware of NXP is this that they can buy?
It's the IMX 8M Plus.
8M Plus.
Yes.
So it's NXP IM 8M Plus.
Yes,
Right.
correct.
So make sure you look out for that one if you basically want to do it. So again, just recapping what we just talked about, we have ML ops, right? IoT is basically on its own. Is basically there's no return on investment value. You have to take the value of IoT data which is generated. Now in this case, images, vision,
Yes.
right? So you gotta take that and apply machine learning to it. And machine learning basically on its own is basically nothing,
Correct.
right? So you gotta basically marry up IoT and ML,
Correct.
and then make an awesome package where we talk about you take the package, you make making people's life easier,
Easier.
yeah, and basically deploy it by using ML ops,
Correct.
right? So this is great. Now let's switch up a gear, something which is very close to my heart, security, right? So let's talk about how easy it is to provide updates, camera security updates to these devices that are already deployed in the field.
It's not easy. So again, remember the billion number that I mentioned, right? So there are a billion cameras installed. These cameras have been installed over a long period of time. And if you dial back 10 years, I don't think silicon vendors or OEMs really looked at bottoms up security
Yeah.
all the way to the camera level.
Yeah.
So I think but the world is changing. So we have a lot of initiatives on our side. Like one of the examples is what we call platform security architecture, where we work with silicon partners, we work with OEMs, ODMs, and even some of the services that you provide, so that we could do security updates.
Right.
We kind of use some of your OTA services so that we know that when an update is being done, it's done in the right way and it's secure.
Yeah.
But I would say there's a lot of work to be done. We are pushing our value chain to make sure that the silicon is secure first.
Yeah.
Then at the ODM level, the ODM is securing everything, and even OEM is securing everything. So we're trying to really emphasize security across the value chain.
That's awesome. That's really awesome. I mean, you just basically mentioned the really goalpost when we're talking about OEMs, ODMs, security. So for the viewers out there who are basically watching this, we have a workshop called Get Started with AWS You can go to the workshop and you can actually go ahead and play. We have a module in there regarding firmware update. So exactly what Parag mentioned is that you can have AWS IoT jobs, apply the firmware update when the security patch is needed to your end device. So yeah, it is a painful process, but we are doing all we can as a joint collaboration at AWS and Arm to basically make sure we make developers, builders, and obviously consumers out there life easier, secure, and safe.
So this is also a part of this is where virtual hardware could be used as well to test out the whole flow.
Yeah.
And then if it works, then you go deploy on real devices.
That is awesome. I mean, that is something I'm definitely going to go and try because I've been playing with Arm virtual hardware for a while and I love it, right? And because that way, it basically don't have to mean that I have to go and buy a hardware because I know it is provided by Arm. So I know for a fact that once I build on it, I would be able to run it. So if I build it on my machine here, I test it on Arm AVH, I could actually deploy it on Graviton, which is our Arm implementation on the cloud part. Or in fact, you can use the AMI of Arm to run it on Graviton. There's plenty of options out there. We are doing as a collaboration, make your life easier to go ahead and get started. Now, let's switch up a gear to people out there in the marketing or finance buff who wants to basically talk about the cost, right? So let's talk about how many of you are paying for camera services in your homes.
Yes. So I think this goes back to the video surveillance as a service concept.
Yeah.
I think traditionally what happened is many of these OEMs shipped these cameras and they were done.
Yeah.
Right? But as time progressed, I think it's an amazing change in business model where you're paying services that you only need instead of this whole box of services. Right?
Yeah.
So I would say currently Ring is a great example where you pay $299 or $399 per month, and then you
pick and choose what you want.
Yeah.
So, for example, I also have a ring setup, and I pay, I think, $299 if I remember correctly.
Yeah.
And I only need 7 days of footage.
Yeah.
And I don't think I need anything beyond that. But this is on the home cameras. But if you go to commercial cameras, there are quite a few number of companies which provide you 7 days, 30 days, even 365 days.
Yeah.
So it's really a business model change that's happening. And actually, in 2 weeks, there is a conference called ISC West, where we are also planning to be there, where we want to really see where the industry is trending towards. So I think it's a really game-changing thing that's happening for in the camera market.
Awesome. Yeah, I mean, it makes our life a lot easier to keep an eye on our property, our assets, and our children.
Yes.
You want to make sure that if you're traveling like we are, and you gotta make sure you got a ring there. You want to make sure your children comes home on time and they actually not taking the muddy shoes inside the house, right? So you want to make sure that the ring is there for you, right?
Yes. And the $2 or $3 is worth it.
Yeah,
per month, right?
exactly. So I couldn't put it better. I mean, definitely it's worth it. It gives us the peace of mind that our family is safe. Yeah, definitely.
I can give you an example too, actually. So where I traveled back to India for 3 weeks.
Yeah.
And we had a package that was supposed to be delivered.
Yeah.
It was not delivered before we left.
Right.
So as soon as it came through, we told our neighbor, "Hey, the package is there. Go pick it up."
Yeah.
And definitely it's worth the $2 or $3.
Oh yeah. Obviously.
Amazing use cases.
Yeah, exactly. So if you had delayed delivery by Amazon, then obviously you have raincoat backing you up. You basically get a neighbor to pick you up. I often have the same situation as you. Because obviously we can't control the traffic, we can't control the environment around it, and obviously this is where we're making technology easier for our lives. We're improving our lives like that. Yeah. So we are closing towards the end of the session. I do have one or two side questions for you. So let's talk about, what do you expect to improve in cameras in your home? We already talked about these. Let's go deeper in that.
Yeah, I think first is, if you again look at where cameras are being used, they are, as you said, being put in front of the houses, back of the houses, or even in certain locations, basically for monitoring.
Yeah.
But as a consumer, you expect the devices to work whether it's raining, whether it's snowing, night at 12 in the night, or 2 a.m. in the night. So some of the problems related to these are low light is super important.
Yeah.
So being able to recognize the same cat that's roaming around in low light. So imaging is also a key thing where there's a lot of focus in the smart home camera market.
Yeah.
And then I think we touched upon a few things, right? Machine learning, security, because in the past there were few cameras that were hacked.
Yeah.
Which I don't think anyone wants to see that. So that's why security and machine learning are also super important.
Exactly.
So I would say imaging, machine learning, and security are 3 areas where we should see a lot of improvement in home cameras.
So this is exactly as you said. This is the collaboration of multiple technologies bringing into one domain.
Yes.
I.e., in this case, smart cameras, right? And I mean, we can talk about it whole day. What cameras can help our life, improve our life, enhance our life. This is where we are listening. Arm is listening from our developers. The pain points they're experiencing when it comes to building these products. We as AWS are listening to the pain points we are basically seeing from developers, and we are basically working wherever we can jointly, collaboratively, to make sure we make the life easier of our consumers, our builders, our developers, our consumers, right? So this is all I had from the questions perspective, and we are edging towards end of the session here, Parag. It has been absolute pleasure to have you on this session, Parag. And if you have any closing words for our viewers out there, any nuggets or surprises you want to drop, go ahead.
Definitely closing points. I don't have any specific surprises, but I think cameras are going through a huge fundamental shift.
Yeah.
I think they're going to be part of your life moving forward.
Yeah.
and you will see them really enhancing the lives of people in whether at home, at work, or even when you're in a stadium shooting for your favorite football game.
Yeah, exactly.
So I think they're going to be an integral part of your life,
Yeah.
and we are working closely with AWS through many angles to make sure the whole value chain benefits and cameras become really helpful for future deployment.
Exactly. So great pinpointing there. I mean, you have Bundesliga, which is the football league in Germany. We have NFL in US. AWS technology is augmenting with cameras,
Yes,
exactly.
yes.
And machine learning is basically making life easier for those sports funded. So with that, thank you very much.
Thank you.
And to our viewers out there, keep watching. We have a few more sessions before we finish the end of the day. And it's goodbye from me. Have a great day. Bye-bye.
Thank you. Bye.
Bye.
So hi everybody, welcome back to Embedded World live stream. I'm Nenad, as you got used to me, and I'm joined with Frederick, and we are going to talk about open source and IoT at Edge. So maybe you can introduce yourself.
Yes, of course, and thank you for the opportunity, Nenad.
Thank you.
So I'm Frederick, and I manage IoT and edge computing programs at the Eclipse Foundation. I'm a kind of evangelist as well, out and about trying to tell the world about those incredible 50 plus open source projects we have in the IoT and edge space. And as part of that as well, I wrote a little book available since December. You can find it everywhere. And really, if you know, we'll have the short version today. If you want the long version or to put yourself to sleep, then of course you can buy the book and have a look at this.
No, it's pretty cool. I mean, once you mentioned this like open source, I know Eclipse IDE, right? I think everybody knows about that.
Yes.
But are there any other open source projects that are related to IoT that you want to mention?
Yeah, absolutely. So overall, we have over 50 projects at the Eclipse Foundation that are straight about IoT and edge. And then from a broader perspective, we have over 400 projects total at the Eclipse Foundation. So IoT was the very first domain where we expanded away from development tools. For a long time, the foundation was just development tools. And then it grew with IoT and edge and in other directions. So if you come at our booth here at Embedded World, you will see software-defined vehicle, you will see research projects, you will see so many other things. And that's the thing. I mean, the IDE is still around. If you love it, please continue to use it. I mean, there are 6 million active users of it, so I guess still some people love it. But of course, there are other tools, and that's fine. We have a cloud development tools working group that are building browser-based IDE, or at least platforms for some others to build, cloud-based IDE. So that's the thing. We've been very bad at marketing, letting know to people that we are much more than the IDE. Now, from an IoT and edge perspective, we have several projects that are probably the Linux distribution that you actually use. For example, the Eclipse Mosquito MQTT broker. It's in every distribution, apt-get install. That's from Eclipse. I didn't even know that before joining the foundation. Can you? I mean, that's funny. Then Eclipse Tahoe, which is a set of MQTT clients, very popular. We've got things like protocol implementations for everything, co-op with Eclipse Californium, lightweight M2M in Eclipse Nation, DDS with Cyclone DDS, and innovations that are not third-party protocols, but things that spread out the work of our committers like Eclipse Zeno. And Zeno is really exciting because it's like DDS. It can be peer-to-peer, but they introduce this notion of a routing node. So, you can broker it, or you can be peer-to-peer, or a mix of the two. But it routes well over the public internet, which is not the case with DDS. And Zeno is written in Rust, so that's trendy and sexy. But you've got bindings in Python and Java and other languages if you want
to check this out. I never heard about this. I mean, I know about DDS, co-op, and PTT. Zeno, I haven't seen it. So.
It's really on the rise. That's one of our star projects. And all of this to say that we have an incredible community of over 1,800 committers overall in all of those projects. Some of them are more active than others, of course, but this is a growing community, and there's probably something that you can use if you are an IoT or edge computing.
No, I was about to ask this. So, I know open source is, have been playing an important role in developing general software, but when it comes to IoT, there has been not that many adoptions, but I think Eclipse is kind of moving this forward with all of these technologies and open sourcing them. You seen this kind of movement?
Absolutely, absolutely, and this is because of one thing. This concept of the value line. When you have, let's say, things that are commodities below the value line, and things that are innovations for which people will pay above the value line. So the thing is, when you think about it, I've been around the industry, unfortunately, for a while. I don't have hair anymore. When I was younger and I could pull my hair, you were paying for everything. Compilers, IDEs, everything. That was so expensive. and we had CRTs. Oh gosh! But the thing is, nowadays you don't pay for many of those things, and even when you have paid services, those services more often than not are built on open source software.
And even those, so I mean, sorry to interrupt, but like even things that you have been paying in the past, they were actually not contributing to the main business. So it's like an underlying infrastructure that you just need to use, but you still need to pay for it in order to kind of allow you to build things.
Yes.
And I'm happy that there's this movement to open source, which like allows you to kind of like have that for free, as you said.
And that's because, I mean, in today's economy, you want to focus your R&D at the top of the stack, so to speak, where differentiation is, where innovation is. So if you waste your time literally reinventing the wheel for commodities, I will write my own operating system. Very productive, right? So
could be fun though.
Yes, of course. And I mean, and there's still place for innovation in that. Yeah. But if your operating system is just Linux with a different name, then you wasted your time, right? So you need a bit more than that. So overall, open source is a great production model. It's not a business model. It's a production model that enables people to pool resources to build things together, even with your competitors, right?
Yes, exactly.
And then once you have that, you can add value at the top and keep some things commercial because, of course, well, someone needs to pay for the bills.
Yeah, no, I really like this explanation. So we had this people from Automotive Grade Linux as well, and it's amazing to see this. Competitors like the main automakers, like all of them are joined together to build that infrastructure.
Yes.
So that they can have a specific bits and pieces that they think are important for their customers.
Yeah. And we see that happening at Eclipse in our software-defined vehicle working group. So in our case, we are a bit higher in the stack, but we have literally building blocks that enable those car makers to mix and match whatever they need. And then, of course, they can design their shiny thing that when you start the car is proprietary to them.
No, this is pretty good. And I really love that this trend goes into the IoT solutions as well. So, but speaking about this, open source, you also have like different standards and whatever. And I heard that there's like this thing called Sparkplug. Maybe you can tell me what that is.
Yes, absolutely. So you're quite familiar with the MQTT protocol, right? So one of the great things about MQTT is that you can publish anything, anywhere. Fantastic, yay! One of the bad things about MQTT is that you can publish anything, anywhere.
Yes.
So out of the box, the problem, I have this robot, I have this piece of software. How do I integrate them? Even if they speak MQTT, both of them, I have no idea what the payload is. So I need to massage payloads. I need to figure out a bridge that will subscribe on one side and report. That's wasted time, right? You don't produce anything useful doing that. You're just doing integration work. So essentially, MQTT has been invented in 1999 by two people, Arlen Nipper and Andy Stanford Clark. And in 2016, Arlen Nipper, who had moved to other things but was still in industrial automation, created the Sparkplug specification. And then he realized, well, if I want to grow this, the problem is that my competitors and even my customers, they don't trust we are in this for the long term. How do I drive adoption for Sparkplug? And I will explain soon what it is. But essentially, how do I drive adoption for it if it's just me, if it is controlled by my company? And so he contributed the Sparkplug specification to the Eclipse Foundation. So we have had since 2018 open specifications at Eclipse. We're not just about code. And we've done that initially for Jakarta EE, the successor to Java Enterprise Edition. And this is a massive set of specs. It's really complicated. Sparkplug is much simpler. It's one spec. But we are using the same very mature process that Jakarta EE uses in order to manage Sparkplug. So Sparkplug is literally three things that make interoperability possible on MQTT infrastructure. So it's about standard payloads, standard topic structures in a namespace, and then stateful session management. So the payloads are standard in the sense we're not trying to do like OPC UA with the information model where we try in advance to think, oh, this is the ideal water pumps and it's got, that's complicated. I'm not saying there's no value in this, but that's not what we are aiming for. I mean,
Scalable
those data
device,
models already exist, so we're not replicating that. But Sparkplug payloads are generated in the sense that they can express any metrics. And so we have a Google protobuf schema for that. So any Sparkplug client will use that, and then the payloads are binary on the wire. And the way that the spec is written enables you to have data sets or matrices of metrics and templates, so that will reduce the size of the payloads even further on the wire. So that's one part of the equation. Then there's the namespace. So essentially the namespace is versioned in Sparkplug for the topics. So we start with SPVB10. So essentially this expresses that we are using payload format B. There was a briefly lived payload format A that's not used anymore. Now we are at B, and it's version 1.0 for that. Now the committers are working on the next version, so maybe it will be Sparkplug C, or maybe it will be Sparkplug B.
And the only thing that will
Yeah.
change is the actual MQTT topic, right?
Yeah, exactly.
And apart from the
exactly. And so by putting the actual payload encoding at the start of the topic structure, we make sure that we can have multiple versions in parallel on the same MQTT broker. And then after that, there are several attributes that are predictable in the namespace to make sure that you know where to find the information. And this means out of the box, if you have Sparkplug compliant devices or software components, they will be able to interoperate straight out of the box. The third element is stateful session management. You know, one of the most, I'm not sure, do you have kids?
Yeah.
Okay, you have kids. Are they old enough to say, are we there yet in the car?
They are.
They are. So that's the thing. Are we there yet?
Yes.
Okay, once is fine.
But
are we there yet? After 5 minutes, it's even more.
It increases the frequency.
Yeah, exactly. And so both parties in that transaction, so to speak, are wasting resources, and that annoys you. So we see the same pattern in industrial automation with polling. You poll your devices to know if they are online or to get the latest data. Problem with that, you're wasting bandwidth, you're wasting resources, that brings no value.
I mean, this is why the MQTT and the PubSub kind of evolved, right?
Yes. But the thing is, even in plain MQTT, not everyone uses the features that enable you to avoid those kind of polling scenarios. And that's why in Sparkplug, you don't do polling, you do report by exception. So we use retained messages, and we use last will and testament to make sure that at any given point in time we know if devices are online or not. And this is the principle of birth and death certificates. So when a Sparkplug device joins the network, it publishes a birth certificate saying, here are the metrics I would be reporting about, and I am online. And then you set the last will and testament for that device, as the death certificate in Sparkplug format. So between the two, you don't need to poll the device to know if it's online. You know there's the MQTT session. But at the same time, Sparkplug supports both persistent and non-persistent connections. So if the device goes to sleep, the MQTT session can still be active, and it's still considered online, so it still can receive messages.
This is pretty cool. And in that birth certificates, what is the information that gets transmitted?
So essentially, there are a number of properties about the device, and then a list of metrics that it will report about, including their types. And so you know in advance what the type for everything would be.
It's like a service discovery, more or less. Like
you can see it as auto discovery of the nodes, but in this case, it's literally the node publishing to the world saying, "Hey, I'm there." Yeah.
No, this is really cool. I really like this. So and can this be used on constrained devices, like running real-time operating systems, or?
Yes, up to the point that they support TCP and MQTT, of course. That's the thing. If they don't, well, then you have this principle that there are edge nodes in Sparkplug, and edge nodes can have devices or sensors connected to them. So let's say you have Bluetooth sensors, and then you bridge that to a Sparkplug edge node, and then you do everything else in MQTT. But the principle is the same. They will use the protobuf schema. So as long as your MCU is strong enough to do protobuf and encode the payloads properly, then you are fine. And the one thing to know about is Sparkplug is an open spec, So that means it's developed on GitHub in public.
Excellent.
Anyone can implement it free of charge. You don't need to be a member of the Eclipse Foundation. Anyone can even use our technology compatibility kit or TC kit to validate their implementation free of charge once again. The only thing, we have a compatibility program just for our members that gives them access to the Sparkplug compatible logo, the hottest thing in town.
Yeah. No, but this is I like the model, and it's pretty good. I actually now I need to read about more Sparkplug
And
because
that's in the book, so
Is
please
it-
buy a copy.
excellent. Will do. Yeah. No, this is pretty cool stuff. But as I mentioned, coming back to this microcontrollers, like
Yes.
I know that there are like advantages and disadvantages of like having real-time operating system and like bare metal, especially when we're developing those IoT applications. So maybe you can tell me about this. I mean, also in the context of Sparkplug, if you want. Right?
Yeah, absolutely. So the thing here, of course, is that when typically we think about microcontrollers, we typically associate that directly with real-time operating systems, and with good reason, because for many use cases they are a good fit. I mean, Amazon is supporting FreeRTOS, that's a very popular choice, but there's Zephyr, there are many choices, open source and quality code that you can rely on. But the thing is, real-time requirements are not necessarily useful for every type of project. For example, let's contrast two types of projects. You are designing the microcontroller to drive the ABS brakes in a vehicle.
Yeah.
Versus you are designing the smart and connected convention center.
Yeah, completely
Okay.
different use case.
Yeah, the connected convention center, I would have sensors and actuators even to control heating, cooling, temperature, things like that. And I will measure, of course, temperature, humidity in every room and things like that. But it's not critical if I miss a reading there. It's not critical if the valve is open 2 seconds late. So there, maybe I can go cheaper and take a bare metal approach on my microcontroller, and I will be fine with that. And then maybe I have a simpler stack, and maybe it's simpler to code for beginning developers.
Yeah, you can
know?
use the footprint actually, the microcontroller.
Yeah,
and maybe it's even cheaper to get one. Yeah.
Exactly. On the other hand, of course, when you have something mission critical in a factory, in a car, whatever, then you need a real-time operating system, because then you need, and real-time OSs, if you're less familiar with the concept, I mean, they are not about performance. They are about guaranteed latency, which essentially means I know if I execute an operation, the process will come back, to the next line in X microseconds or milliseconds, depending on the platform and how you configure it.
Schedule your threads, and
Yeah,
then you can know
exactly,
exactly when
exactly.
it's executing with the highest priority, lowest priority, all that
Exactly.
stuff. Right?
But then it's not a magical solution in the sense that if you write bad code that's low performing,
Yes.
you will run into problems, right? But at least the RTOS gives you a guarantee that on a predictable cadence, your threads will receive processor time, and that you can process the interrupts that come in real time. And that's the whole point. So for your ABS brakes, that's a perfect thing. So really, in the book, I described several open source real-time OSs, three of them, so Zephyr, FreeRTOS, and Arm Embed. And on the other hand, I contrast that with Rust, for example, as a bare metal solution for microcontrollers. And both approaches are viable, but don't go in blindly. Do evaluations of your use cases, figure out what your actual requirements need, and then pick the stack that makes sense for you according to your skill set, what you're comfortable with, and of course, the community support and the hardware support and things like that. Yeah.
So we've seen Rust now getting popularity, especially for this, like, in the safety critical environments, because it has that guarantees out of the box. So, and as you said, if you don't need a scheduler, and you don't need some of those primitives that real-time operating system offers you. You can just use Rust more or less in a bare metal.
Or even, you think about Arduinos. You do Arduino sketches for very simple scenarios, and that's fine too, maybe.
Yeah.
But think about it. Don't jump blindly.
Exactly. Okay, I think we already are running out of time. This is a really interesting conversation. Definitely we need to invite you on the IoT Builders to have like a longer conversation. It's like so many things to talk about.
Yes.
Anything else you wanted to add for the end of the session?
Well, first, thank you to you and the team here that helps produce the live cast. Really appreciate it. And then the other message, please make it your mission in life to tell all your friends that the Eclipse Foundation is not just about the IDE anymore. Okay, it's still here. If you love it, it's not going away. But if you don't like it, that's fine. We have plenty of stuff for you. And the other message, maybe, since we began this conversation
Yes,
about
please.
open source, the true value of open source, something that it's in consuming the technology. Oh, I can download this for free and, it will be easy for me. And that's part of it. But really, the actual value is when you start contributing
Yeah.
to the projects.
Yeah,
And we have members, big industrial companies that tell us we are here because essentially I have to pay, yes, 20K or something to be a member of the Eclipse Foundation, but I save so much money by being involved in the projects and being at the center of all those decisions. And of course, from a personal standpoint, if you're a developer, being an open source developer, whether part of your day job or as a sideline, is certainly a great way to network, build relationships, gain skills, and all of that. So please, don't consider that the value of open source is in consuming, it is in contributing. And so you are welcome to contribute to our 50 plus IoT and Edge open source projects at the foundation at any time. Really, this is open to anyone.
This is a great message. Love it. Thank you so much. Thank you so much. Okay, everybody. I think that's it for this session. Hope you enjoyed it as I did. And we'll see you back in a couple of minutes. Bye.
Thank you.
Hello and welcome back. We are live streaming from Embedded World, and this session is called How to Make Connected Products with STM32 microcontrollers and AWS IoT ExpressLink. I'm joined by my colleague Anton Schmegen. Hey Anton, how's it going?
Good. I mean, busy, but pretty good. I mean, we're lucky to have Embedded World more live this year. Last year it was very slim.
That's right. And actually, speaking of slim, we have a guest that we're going to be bringing in
Absolutely.
remotely, and his name is Slim Jaluli.
Hello. Hey Dan.
Hey,
Hey
Slim.
Anton.
We can hear you just fine. How are you doing?
Okay, that's good. Yeah, I hear you very well. Yeah, I'm doing good. Thank you. Thank you for
Sorry
inviting
for
me
waking you
today.
up.
That's fine. That's okay.
Yeah, so Slim couldn't be here in person, but we're bringing him in remotely. Thanks for joining today, Slim. Really appreciate it.
Yeah, thank you Dan for inviting me. Thank you.
Yeah, it's been a good show so far, wouldn't you say, Anton?
Absolutely, yeah.
yeah.
Very busy. We have very good session with ST, very good session with our ExpressLink partners. It was a blast, and in general, the customer engagement is also really good. Maybe we'll let Slim to introduce himself.
Absolutely. Hey, Slim, why don't you introduce yourself? Tell us a little bit about your role and the company you work for.
Okay, so my name is Slim Jaluli. I'm a principal application engineer with ST Microelectronics. So I've been working with ST for a long time now, and basically mostly with microcontrollers. And now I'm the lead engineer for the IoT and cloud applications team in the US. Uh, basically, I work closely with cloud partners, like AWS. And what we do is we work together to enable our devices and boards to connect to AWS and allow our customers to easily connect to AWS and enable their applications to be connected and you know uh, bring in new features and and connect to cloud and use the IoT. So that's what
That's
I do.
great. That's really great. So you've been doing some interesting work lately on projects using STM32 microcontrollers. Maybe we should talk a little bit about some of the collaboration that we do with ST, and this goes back quite a ways. You've been working with ST, Anton, for some time, and I know Slim, you've been working with AWS for quite a while, and you have quite a number of device qualifications that are part of our
Yep.
partner device catalog. As a matter of fact, we're featuring a lot of the devices here at the AWS booth in Hall 4. We have
Okay.
what's known as the device wall, and so we have various partner devices featured on that wall, and I'm sure we'd see quite a few ST parts there.
Absolutely. So we have both microcontrollers and MPUs, like STM32 MP1. In fact, one of the colleagues from DH Electronics just standing outside, and it's industrial gateway that using STM32 MP1. We also what we called built a couple of years ago a reference integration with STM32 U5. It was first reference integration for connected Cortex M33 microcontrollers, where we're featuring TFM, trusted firmware for Cortex M devices, and obviously secure provisioning, secure order updates, and all this stuff. In fact, we have a demo at our stand with STM32 U5, and lately, and this is hats off to Slim. We start building this kind of ecosystem of devices with STM32 microcontrollers, the whole range of those, including from very tiny C0 that was just recently announced,
Yeah.
G0, and up the stack U5, up to the super powerful H7. So basically, any nuclear board, ExpressLink shield from one of our partners, and then the sensor shield on top of it, which actually gives really rapid platform um, for developers to experiment, because ST has variety of families, and even within the families, a number of kind of packaging and different SRAM sizes, flash sizes. So this is really incredible. And Slim, as I said, was instrumental to building what it called iCube ExpressLink, that you can freely download from STM32 hotspot and start experimenting yourself.
Yeah, so let's dig into that a little bit. You mentioned that this reference design here includes an ExpressLink, and that's really a perfect pairing with STM32 microcontrollers as the host processor for the application, and then with the form factor the way it is and the Arduino headers, it's really easy to plug in an ExpressLink on top of that and basically use that for connectivity to AWS.
Correct.
Maybe talk a little bit about that that reference design that you did, Slim. And,
Sure. Yeah. So the ExpressLink from AWS, really, it's a great idea and a great new addition. Really makes the IoT developer life much more easier, because he just needs to deal with a few AT commands, and he is connected, and he can be connected, and sending telemetry, and sending and receiving MQTT messages, and only he need to do is a few AT commands, and this is really great. But what I did is I took it one step further. I make it even more easy, because you have to deal with AT commands. You need which AT command you need to send, and also you will receive events, and you need to handle those events, and okay, what they're gonna do with these events and stuff like that. So
yeah.
the idea here,
So it took you a little bit to just get used to the AT command set and
yes,
and use those, but
yeah,
but
yeah.
continue. Sorry.
So I developed this ExpressLink driver for STM32, and basically you don't need to know the AT commands. So they're simple functions calls, like ExpressLink connect, ExpressLink set SSID, ExpressLink set password, ExpressLink set endpoint, ExpressLink send message, ExpressLink receive message. Very simple. That
I
makes
see.
the
So they kind of
developer.
map to the AT command set, is what you're saying.
Yeah, in the line they map to the AT commands, but the developer, he doesn't have to remember all these AT commands, format them properly and everything. So the underline, the function will format the AT command properly and send it to the Express link. And with this example, we have the hello world, the very basic example. It's like probably 5 lines of code, and with
Oh,
five lines
yeah.
with 5 lines of
Yep.
code, you are up and connected and sending data. And
Wow.
also, what is great about it, the code size is so small, that can fit in SMT2 C0.
Yeah.
So, for example, with the C0, the hello world takes about 5 kilobytes of or 6 kilobyte of flash, and less 1 kilobyte of RAM. That tells how small it is. With that small amount of flash and RAM, you're able
Yeah.
to connect to AWS and send and receive data.
That,
And
yeah, that's a really good point, because that
yeah,
sometimes maybe gets overlooked when you talk about ExpressLink. Is you're not only getting the security and the encapsulation of the code base in order to connect to AWS, but you're also really reducing the footprint of your own application, so that you can be a lot more nimble with
yes,
what
yeah,
you choose to do with your application. So
correct,
you
correct.
don't have to blow out of memory and flash just because you have to have a large networking stack, for example.
True, true.
Yeah. And I also want to point out that on a ST sensor shield, there are already some of the sensors present, like humidity, temperature, humidity, accelerometer, but it also has a form factor to expand to almost uh, entire range, entire number of ST sensors. So basically, this open up even more kind of opportunity for developers very rapidly, quickly assemble something, no wire required. We know that it's gonna work, right? And
Yeah.
using the CubeMX, the code generated for your sensors,
Yeah.
the code generated for your ExpressLink, and the only you need literally write just like a glue code
Yeah.
to uh, to kind of highlight your functionality. And obviously, the moment the data is going into the cloud, you can fan it out to any AWS database or service whatsoever. I mean, like TimeStream or DynamoDB.
Yes.
Uh,
Yeah.
Yeah.
So
Yeah.
as
This
as
iCube. Oh, I'm sorry. Go
yeah, so
ahead.
as Anton said, the iCube, it's a SIMSys pack, in fact. Also, that has been enhanced for SMT2 CubeMX.
Yeah.
And what is great about it, you can basically zero code. You don't have to write any line of code. You just open the project. You can select your microcontroller, import the SIMSys packs with CubeMX, and also CubeMX allows you to configure these these stacks. You can import FreeRTOS, you can import the Xcube ExpressLink, any stacks, and you configure them with the CubeMX, and with a just click of a button, you generate a working project. You don't even have to write any C code,
Wow.
and
So
the
you just
project
went
is
from 5 lines of code down to 0 code. You just said.
zero. Yeah, after that, it gives the basic example that connects, and then after that, you have to write your code on top of it. But the basic initialization, everything, it's done for you, and you don't have to touch anything. And
Got it.
basically, yeah, what brings here, so we have in SMT2, we have more than 3,000 part number, probably 3,500 part numbers. And this, like in 2 3 minutes, you can select your microcontroller, anyone you want, from a C0 up to an H7 dual core. And you can select any microcontroller, and basically in 2 3 minutes, you have a working project, and you don't even have to write any line of code.
and then sizing, let's say upsizing or downsizing to save the cost, becoming really, really easy because you can actually prototype it, not guessing something, but you can actually whip it out. And I have to point out because every ExpressLink has built-in over-the-air update. This is something that many companies overlook how difficult to make it happen, but ExpressLink makes it very, very tangible, and we kind of the responsibility and shared responsibility model comes to us, right, to AWS. So we kind of making sure that it's secure, it's going to be updated, not only ExpressLink firmware, but you can update the firmware on application processor. That is responsibility for customer, obviously.
Yeah.
How it's gonna happen, but it simplifies tremendously this uh, uh, a lot of difficult points, right? Certificate rotation, over there update, your onboarding. So I think it's really, really good match. And when we present it to some of professional developers ExpressLink, their initial reaction was, it's like a toy. But then they grasp that it's not about, you know, who can write better code, but it's about the long-term maintenance, and um, it's about faster time to market as
Yeah.
well, and lowering the risk for both companies, because we know how ExpressLink developed, and we're putting a lot of engineering time as AWS there, but it also lowering the risk that something will fail for the production product, because I mean, experimenting is cool, 1 2 3 devices. When you're shipping in 100,000, that's a different gameplay.
That's right. Yeah, that's true. And you know, what's really cool, I think, too, about Slim's work with the iCube ExpressLink and the Simsys packs is now you can use that for development, like you've got there, but now you can design in a STM32 microcontroller for your production board and drop down a ExpressLink module as well. And so it really literally scales from prototype to production.
Yes.
Wouldn't you say that's the case, Slim?
Yeah, that's the case. Yeah, you can drop in, any Express link in there, in your production, and with CubeMX really is very flexible. So you can change your configuration. It's very easy. A few clicks, you can change your pinout configuration. You can change the microcontroller. You can change your stacks configuration. You can swap sensors. It's very easy. And it's very convenient. And as Anton said, and you said, for example, with OTA, firmware update. Traditionally, the customers, they have to write their application on the microcontroller, and then they have their connectivity module. And okay, we have a way how to update the main application, but how are you gonna update the main communication module? And which is
Yes.
difficult. And you will have different vendor, and each vendor will have a different way how to update it and things like that. But with ExpressLink, this unify this update mechanism. You select an ExpressLink module, you know that updating the module, it's built in the ExpressLink, and also updating your main application is also there. It's easy and it's unified. You don't have to think too much about it.
Yeah.
And also, what is very important, like you can select Wi-Fi or you can select cellular, and
Oh yeah.
swapping Wi-Fi and cellular is very easy also. But
Yeah, that's
traditionally,
true.
yeah,
Normally, it's not so easy to swap cellular and Wi-Fi.
it's not so easy, yeah. But this, we will make it very easy for the developer to swap. Okay, I have Wi-Fi, but I want to go cellular. It's just you swap the module and it should work. Very
It's
easy.
true. You know what I like too about the work you did is that you've got working examples in your
Yes.
GitHub repo
Yep.
that feature FreeRTOS and all the different boards that you support.
Yes.
You're even using the JSON library from the FreeRTOS core
Yes.
set of libraries, right?
Yeah. So the example, the Simsys pack, so it does have a few bare metal examples, like show you how to do pub sub example, a shadow example, and things like that. Very simple. And also
Yeah.
we have other examples that use FreeRTOS. And
Okay.
the
Yeah.
example that use FreeRTOS, so we'll use we send messages, telemetry messages, and also we do the shadow. We handle the shadow messages, and then using the FreeRTOS JSON library to handle the, um, the shadow messages to parse the JSON documents, which make it very easy.
Yeah. Yeah. Oh,
Yeah.
that's awesome. Yeah.
And as actually the boards are running connected to Frankfurt region, sending telemetry, sending accelerometer data, we can actually visualize. Sorry, we cannot, due to the format, we cannot show it on a screen. And sorry for the ambient noise. It's busy. It's busy.
There's a lot going on here.
Yep. So I think we will need to wrap up pretty soon.
That's right. But thanks a lot, Slim, for joining us remotely. Really
thank you.
appreciate you participating, and great work on everything you're doing with the ST the iCube ExpressLink. I think it's just amazing work. So if you're a developer and you're using STM32, which is one of the most popular microprocessor platforms around, check this out because it's really easy. Slim has basically made an easy product even easier to use, and
kudos.
It's really great. So
Absolutely. And I've been at ST booth yesterday. If you're at Embedded World Show, they have a big cubes of C0s, that development boards that I think they're handing out to
Oh,
potential
wow.
customers. So, I mean, check it out and pair it with one of our ExpressLink partners and just start developing.
Awesome.
All
All
right,
right. Well,
thank
thanks
you.
again,
Thank you.
Slim.
Yeah,
Yeah,
thank you for inviting me.
appreciate
Okay,
it.
bye
And
bye.
thanks, Anton.
Thank you.
All
Happy
right.
embedded
All
world.
right, bye bye.
Yeah,
Thank
so
you.
stay tuned. We have more sessions coming up, but bye for now.
All right, bye bye.
Hello and welcome back to IoT Builders live at Embedded World. We are at the AWS booth in Hall 4. This is booth 550. We're in Nürnberg, Germany. And joining me today is Joe Julicher. Hey, Joe.
Hello.
And Thomas.
Hello.
Hello. I think we've seen you guys before.
We have been quite regulars on this program in the last couple of days, indeed.
That's right. So this is part 3 of building the AWS IoT ExpressLink demo badge. It's the fastest path to connectivity, and you're going to tell us how you did it, developing with the demo badge hardware. I think in this session we're going to talk a little bit more about what always ends up being the end of the process, which is software.
Oh, I thought you were going to say security.
Oh, well, security, yeah. Well, you know what's great about ExpressLink is you don't have to worry that much about
It's
security.
built in.
So you probably didn't have to do that much with security, huh?
Not this time, but it's always an afterthought.
Yeah, yeah. Okay, so let's start. Let's do a little bit of a recap of part 1 and 2, which you've already done. But maybe explain a little bit about the demo badge and first of all, what it is and why you did it, and what we've covered so far.
Sure. So on Tuesday was our first part of this series. So we talked about kind of introducing the AWS IoT ExpressLink service itself. What is ExpressLink? It's, well, a fast and simple way to connect your products to the cloud. And with more and more smart products and smart home, smart connected devices, having that fast and secure way to connect your devices, that's really the key. And that's what ExpressLink is all about. So on Tuesday, we talked about, okay, what is ExpressLink and how did we build our first product, so to say, our demonstration product, which is the demo badge. So we ran that last year for reInvent at our annual conference at AWS to, well, talk about the ExpressLink service and the ExpressLink offering and really showcase it in a real product. We designed the hardware, we built the hardware, we built a workshop actually to educate people on what is the capability of ExpressLink and how can you, the customer, actually build it into your own product.
Yeah, that's great, and it was a gregreat workshop. It is a great workshop. You've repeated it multiple times, but I participated in it myself, and it's just an excellent way to show how to prototype and design a product. Yeah, really great. Okay, so let's see. Where does that leave us now? What things have we left off so far in describing the whole process of this thing? It's software. Did we miss anything else leading up to that?
I think so. I think we did all right. In the first day, we talked a lot about the requirements, how the workshop worked, how ExpressLink makes this very easy to get to the cloud. Yesterday, we talked a lot about how this hardware, the number of prototypes it took to get to the final hardware, and the decision process that went into it. So I think that the software that's running on the host processor and maybe some of the software that we actually ended up putting in the cloud to support the class will be the focus of today.
Okay, great. So let's start with that. Now you made some choices in the software that you used for ExpressLink. You needed something that was going to be able to run on the host processor that you chose, and then also be able to execute the AT command set for ExpressLink through the serial connection. So maybe talk a little bit about that choice and what kind of went into that.
Yeah. Sure. So the expectation on ExpressLink is as many use cases, but one of them would be if you already have an application, it may not have connectivity at all. In fact, we assume it wouldn't because we're interested in ExpressLink. So you want an easy way to connect ExpressLink to an existing application. Well, the requirement for that is just a UART.
Yeah.
And for the class, we needed a processor with a UART. So we chose this Raspberry Pi Pico, the RP2040, because we also wanted to meet the needs of the expected class attendees. So at reInvent, it's a very cloud-focused class. And we don't expect a lot of the attendees to be strong embedded programmers. I do a lot of embedded programming, and it's all C. But setting up a tool chain and thanks to a bunch of cloud engineers, that seemed like maybe we should not do that. So in this case, we chose Circuit Python
to
be the programming environment of choice. And that
And the Raspberry Pi device works very well in CircuitPython. In fact, it shows up as a mass storage device. You write some Python, you copy it into the mass storage device, and immediately it starts executing. No tool change required.
Yeah,
So,
that's great. And that's available on some different platforms, but the Pi Pico in particular is a really good host processor.
There was a lot of, last year especially, there were a lot of supply chain constraints.
Yes.
So we started looking around for microcontrollers. These were readily available in sufficient quantities, and the other choices were they were more difficult.
Okay, yeah. Okay, so that's great. So you started developing with MicroPython. It's really easy to flash those, like you said. It comes up as a device, a storage device in your computer, and you just drop in the files, and it reboots, and you're off to the races. You developed a lot of the software, Thomas. Tell us about how you approached that, and what you ended up doing.
So the first step with building a device and then the software or the firmware for it is always, well, what work have others already done?
Yeah.
So you start looking for like existing libraries, existing drivers to interface with the sensors and the other modules that we use, right?
Yeah.
So we used a very common temperature sensor, humidity sensor, accelerometer, ambient light sensor. And because we chose very early on to use CircuitPython, that community spans globally, and they have just contributed so many different libraries and drivers for all of those sensors. We can just pick and choose whatever we want and say, okay, let's choose a sensor that is already supported by CircuitPython and that community there. They have built a driver, nice documentation. I don't want to spend all of the time rewriting all of those drivers in Python if somebody else has already done it.
I see, yeah.
So that was really the first step, saying, okay, these are the chips that we have, these are the existing libraries we have. What is the remaining gap that we need to fill? And that was actually quite small as a gap. So the only gap that we really needed to fill is what we then ended up calling the batch operating system.
Okay,
so
all right.
It's a very
that's rather ambitious.
It's a very big name for a rather small thing.
Okay.
So it's always easy, right, to just say, okay, let's create a class as a representation, an instance object that represents the batch. And then that initializes all your peripherals, it initializes all the I2C addresses for your sensors, and pulls in all of those modules for you to use.
Yeah, because there's a number of different peripherals actually on this batch. You've got a little screen, you've got buttons on there, and then you've got a number of sensors. And even this LED strip here too, which is actually one peripheral, but five different LEDs. So you had a number of things to incorporate into this application, right?
Exactly. So not only those actual peripherals, but also the ExpressLink. Because it is a serial device, so that's kind of the star of our show.
Yes.
We put it on the badge, we put it top, front, and center because, well, that's what we want to show off with this device. So in terms of gap, as I just mentioned, well, that was kind of the new thing that we needed to integrate. But because it's a serial device, a UART device, it's super simple just to send those E commands, AT commands. You literally need, I think, 3 lines of Python code. Create the UART interface, give it the right baud rate, and then say UART.write, and give it that AT command to connect or to send a message to the AWS IoT Cloud, and you're done.
Wow, that's really great. So that's it then? There's nothing else to talk about? No, I think there's more to talk about. So some of the library development and some of the code that you've done really acts as a wrapper around some of these AT commands, and makes it kind of even easier in a way than interacting directly with the AT commands. And maybe you could talk a little bit about that.
So while it's actually extremely easy to send the raw commands to the ExpressLink, when we wrote different libraries, some in Arduino with C and some with this badge with CircuitPython, we found that you were doing certain things over and over again. Like all the commands, when they finished successfully, they returned OK, and then perhaps some additional information. Or they'll return error with an error code and some additional information. So we started adding wrappers to streamline this, because we didn't want to have the class attendees do something where they're always repeating themselves, you're going to make mistakes. It's going to make it more tedious. So we wrapped all the ExpressLink commands with commands that give you sane, Python-like error codes and Python exceptions, and made a very Python-like interface library. We've also made similar libraries for other environments. So you have a very Arduino C++-like library on our repo, but that library was not used in this badge.
Okay.
So one aspect to that is, of course, the parsing of the return code, like OK or error. The other aspect is, well, we spend most of our time in a text editor. Well, hopefully it's a little bit a smart text editor. It's like an IDE.
Yeah.
So you want some code completion, function comments, header description, which
Highlighting.
parameters do you want to type in.
Exactly.
So that's what these prototyping SDKs now add on top of that. You can just type your raw AT commands if you want, but then you kind of need to have the spec sheet with the AT command documentation next to it, or you rely on that built-in feature of your IDE to pull in that auto completion, code completion with documentations right built in.
I see. Yeah. And so people getting started with ExpressLink, you don't need to use MicroPython.
No, of course not.
You can also even use Arduino sketches. You can
Anything.
use really anything that basically allows you to write serial commands over the UART, which is almost any language.
Pretty much.
Yeah.
Exactly.
Okay. Well, that's pretty cool. So so in your workshop, there are a number of advanced lab modules too that were included. Maybe you could talk a little bit about this. This is after you get through the workshop, doing the coding, getting your badge connected. What else was there?
So one thing we found when we started working with ExpressLink, and I'm an embedded guy. I didn't do a lot of cloud before working with ExpressLink.
Yeah.
Is once you issue the AT plus connect command,
yeah,
you're connected. That it's anticlimactic. So we end up spending the entire time talking about the things you can do once you're connected.
Yep.
So it was a new experience, spending a lot of the time using the services that Thomas was teaching me about, our shadow services and time stream, and the way all this data can flow smoothly into our cloud infrastructure.
Yeah, that's a great point, because we talk a lot about how we make ExpressLink easy to connect, but what is that next step? And the possibilities really are enormous, because you can send data any which way that you would like. Either set up a rule and send it to like a time stream database, or a Lambda function, or even store it in S3.
Right.
There's a number of different paths that you can take with that data. And then even with the subscribe function, also you can bring data back into the device and perform actions based on data from the cloud, not just data to the cloud, right? So so you decided on a particular pattern, which is a time series database, and then
for some of the demos.
So we split it actually into two main chunks for the workshop, right?
Okay,
It was a 2-hour workshop, and we said, okay, let's spend the first 1 hour on those foundational things.
Yeah.
Getting connected, setting up your certificate in the cloud, and onboarding your ExpressLink device the manual way to learn all the nuts and bolts. And then we said, okay, the second hour, now we want to really dive into the interesting parts, right? What would make my product more valuable to our customers? So that, okay, first use case, telemetry sounds really important. Streaming constantly our temperature data, our GPS data, any sorts of sensor data that we can stream into the cloud and then visualize it in the cloud with a Grafana dashboard, or create alerting rules. If you have a cold chain refrigeration unit, we can trigger on certain temperature values, send a notification out. So that then all happens already once the data is in the cloud.
Yeah.
So the job of ExpressLink at this point is already done, because it's connected with one command, the data is sent with one command, and then it's just a while loop that runs every 5 seconds.
Okay. Yeah. So in this example, you were using time stream, you mentioned, and Grafana as the visualization. But you also had this interesting feature with the screen, right?
Right. So the device ExpressLink curates a number of services, and one of the services is OTA. So OTA is where you have over-the-air updates, and you can update both ExpressLink, and separately you can update the host processor.
Yeah.
But for the class, updating the host processor and changing out the code is maybe not the best example. So instead, we updated an image on the screen, and we treated the image as if it was an OTA. So we did a web page that your phone would connect to, and then it would use your camera on your phone to take your selfie, encrypt it, post it to an S3 service, which is a file storage service in the cloud.
Yeah.
And then create a job document. A job document is a way to carefully schedule OTAs and other things into your fleet of devices.
Yeah.
So in this case, it said, go to this place and find a picture. And then the ExpressLink downloaded the picture automatically and cached it, and then informed the host processor that there was an OTA document waiting, which the host processor then interpreted as a picture and rendered it to the display.
Wow. Yeah. So that's great. So then that's part of the software package that you had on the device is figuring out how basically to take those images and render them with the display too.
So that was one of our modules, as we call them for the workshops. We
Yeah.
have those advanced modules now, those use case-based modules, and we gave the participants step-by-step instructions, snippets of Python functions, snippets of Python code that the participants are assembling basically. They are reading through the 3 lines of Python code, understand what it's doing. Oh, it's rendering 1 line of image data while decrypting it on the fly. So I need an image buffer, I need to decode the RGB value, and then it's posting it to the display. And then, of course, the display being already supported by CircuitPython, it's just a very simple command without actually us having to interface with the SPI bus and doing the raw frame buffer magic.
Yeah. Okay, that makes sense. So yeah, so that it seemed like this is a really full-featured workshop because there's a number of these use cases that you can exercise and try yourself. And it's not just sending simple data; it's actually interacting with the cloud, which I think is really where a lot of real use cases fall. Right.
We wanted to hit a number of the areas that are critical to all IoT devices, and over-the-air updates that cover bug fixes, security patches is incredibly critical. You cannot reasonably put out an IoT device without in some manner of doing OTA. So we wanted to showcase the OTA APIs and how that service works, but we just did it by downloading images.
Okay, yeah, that makes sense.
So I always called it, well, we have firmware images. Why don't we use normal images instead? Because it maps nice and it's more visual, right? It's quite satisfying if you see your own picture on your demo badge, fully end-to-end encrypted, just streaming in line by line.
Yeah, that's great. So these prototyping libraries, they're available on GitHub. All of this is open source too.
Yes,
open source.
We have the hardware design for the demo badge open source. It's available on GitHub. You can almost one-click order one of those devices through one of the typical manufacturers and assembly lines. You can download our firmware, our badge operating system, as we called it, as well as the Arduino, Python, CircuitPython, MicroPython libraries to really get started in your IDE.
Yeah.
And of course, the programming guide for the AT commands is available as well.
I see. Yeah.
So those other support, like the Arduino, it's very important because these badges aren't readily available. You can order one with the artifacts that are on the GitHub, but most of us will be able to purchase a dev kit such as this one, and then take advantage of the Arduino sketches to do very similar things in a more embedded-looking environment, not necessarily CircuitPython.
Yeah, and that's really nice too. Some of the ExpressLink dev kits come with the Arduino headers already on them, like this one, and so it's really easy to then take a host.
So that's available DigiKey or on Amazon. You can buy that directly.
And then here you have.
Well, this is a SparkFun Redboard Turbo, which is a SAM D21 based Arduino platform.
I see. Yeah.
And this is a good choice to use for this because the traditional Arduino UART and the USB, they're separated, so that makes this work much more easily. People have tried to use like the old Uno based Arduinos, and that's a more challenging development environment.
Right, because sometimes it's hard to get to the UART in both cases. Yeah, so that way you can basically still interact with your ExpressLink and still interact with your host processor
seamlessly.
Yeah, that's great. Okay, so any kind of last minute points or comments you'd like to make about the badge project and all the work that you've done here?
Yeah, as an embedded engineer who spends most of his time doing hardware and C, this was a fantastic onboarding exercise to the cloud and learning cloud technologies with my data, as opposed to just doing a completely virtual experience. And so I got a lot out of it. It's a very educational time for me.
That's great.
I can pretty much mirror that from the other side, right? As a cloud engineer, I'm familiar with like Grafana and time series database and ingesting data, all fine by me. But pushing that knowledge to the edge and kind of writing that Python code actually on a device makes it also super simple for me, because I write Python all the time in my cloud application, my microservices, and now I can even run Python on an ExpressLink enabled device. So that makes it really quick and easy for me to start.
That's awesome. That's really awesome. So I think we're running out of time here. So unfortunately, we're going to have to say goodbye. This is part 3, and I think it was a great session. But that's the end. So, but it was great having you. Thanks so much for taking the time and spending with us on featuring this demo badge. if you'd like to learn more, definitely check out the GitHub repo. And if you want to know more about ExpressLink, it's on the AWS site. Again, thanks, Joe. Thanks, Thomas.
Thanks for having us.
All right, I think this ends our sessions for the live stream. We have one final session coming up to recap all of the sessions that we had today. But this will be the last one for new sessions. But we've had a great time at Embedded World, and really glad you could join us. And stay tuned for the recap, and we'll be back shortly.
Hi, IoT Builders. We are here with the last session of the day. It is day 3 at Embedded World 2023 in Nürnberg. And we are here for a recap of all the sessions that we've had throughout these 3 days. My name is Alina Dima. I'm a senior developer advocate in the AWS IoT service team, and I'm here with my colleague Dan.
Hi, I'm Dan Gross. I'm also a senior developer advocate at AWS.
Yeah, so we are here to give you a summary of all the episodes and all the interesting things that we have seen and heard for the last 3 days here at Embedded World. Yeah, so day 1 was really the first time we all got together here, and we kicked off some leadership sessions with the AWS IoT leadership. So yeah, that was actually really interesting. We had Dave Kranzler in his role as GM of AWS IoT device software. And yeah, so he spoke about FreeRTOS, he spoke about AWS IoT ExpressLink and IoT Greengrass and Device Advisor. Super interesting stuff.
Yeah, Dave's great. And, he covered all of the different IoT services that we have as part of the AWS IoT umbrella, which includes not only services in the cloud, but also device software. So things like FreeRTOS and Greengrass and now ExpressLink are all part of that software side as well. So yeah, I think he made it pretty clear that, although AWS, of course, is invested in cloud and in services, for IoT, that reaches out to the edge, and that reaches into devices and software, and there's just a lot of great offerings there. So
right, yeah, and then we actually had Richard Berry, who is a senior principal engineer at AWS and also the creator of FreeRTOS. And he spoke about strategy, he spoke about technical vision, and what makes the communities of developers within Amazon and also outside of Amazon really excited and really engaged. So do watch this session. It was a really good session.
Yeah, that's a good point. You can go back and watch any of these live streams that we've been doing over the last 3 days. We've captured them all on YouTube under the IoT Builders YouTube channel, and it's all available to go back and take a look at. So definitely catch some of these sessions if you've missed them live. They are available, and I think Richard of course is great as always, talking about FreeRTOS.
Yeah, we had Richard actually every day in our little recap session, including this morning, and it was really exciting to actually hear his views on security, especially security in embedded systems, and his views on observability and monitoring. So it was really great having him and having him to share his experience as well. And as part of another leadership session, we actually had Richard Elberger, who is the head of IoT Ecosystem Services, and he spoke about embedded Linux as being the most popular embedded operating system. He also spoke about Meta AWS, which is a project that our team is actually working on. He went into details on the kind of work that is actually planned for Meta at AWS and how we are planning to help developers deliver IoT products faster and with more confidence using embedded Linux.
Mm-hmm. Yeah, and we didn't really make too much of a mention about it, but something that we should point out is we're here at the AWS booth at Embedded World, but just within eyeshot, we also see the Yocto project booth, and so things like Meta AWS and things like that are very, very important to the IoT ecosystem. And so we're also supporting, the efforts over at the Yocto project as well. We've got some colleagues over at the booth there. So just a little shout out to the Yocto project.
Yeah, absolutely. Really great work there. And also Meta at AWS is actually fully open source and available on our GitHub repository called AWS for Embedded Linux. And this is where our engineers are actually working. And our team also has a GitHub organization worth mentioning. It's called AWS IoT Builder Tools, where we put lots of samples. I mean, Dan has done some work there. I've done some work there. Our colleague Nenad has also done some work there. So
yeah, that's true.
You can scan this QR code. It will show you, the GitHub organization and also our IoT Builders YouTube channel links and our Dev2 blog as well. where you can, get in touch with us and ask us questions and so on.
Yeah.
Yeah. So we derailed a little bit, but now we're going to go back to the schedule from day one.
Yes.
And we had two very interesting talks. One of them with Jake Wood from Silicon Labs, who was talking about why Silicon Labs is so excited about Amazon Sidewalk, and also what work they're doing using Sidewalk. And then we had Pedro Mendoza from Semtech speaking about how to build on IoT Core device location and how to leverage IoT Core for LoRaWAN, for geolocation, and a very important aspect, what are the benefits of computing geolocation in the cloud versus the device.
Yeah.
Very interesting session too.
Very interesting. And I think that was followed then by the embedded developer approach to AWS IoT Greengrass. And that was a good session too with also Richard and Nenad, right?
Exactly.
And so, that was quite interesting and did go over some of the work they're doing with the Yocto project and Meta AWS, which we've already mentioned. So
yeah, absolutely. So it was also around how embedded developers can get started with Greengrass. What do they have to do? How do the SDKs look like as well? Interesting presentation or talk on open source technologies and Greengrass in particular. Right, and then we had Mike from EBV, an AVNet company, and he was talking about reducing the time that developers take to actually put together IoT solutions and how developers can use IoT Connect to actually accelerate the go-to-market of new products and how to build faster. Also a really interesting talk. I encourage you to actually watch it.
Yeah, fantastic. Where are we now? Let's see. Also stepping through day one was friction-free edge-to-cloud security mechanisms with AWS IoT ExpressLink. That was a really good session as well. Did you catch that one or?
I think that was a session about building security into ExpressLink products.
Oh yeah, that's right. Yep.
Yeah. So that was the session. Feel free to watch it again on YouTube. Everything is there, luckily. So,
exactly.
We had so much material on ExpressLink, haven't we?
Oh, it's been quite a theme for this whole live stream. I don't think we meant for that to happen. Really, it wasn't intentional. But AWS IoT ExpressLink has come up in so many of our sessions.
Right.
It's pretty clear that it's a really popular topic and really interesting, compelling product right now for a lot of our partners and a lot of developers out there who are working on IoT systems.
Yeah, and I think we had also sessions touching a little bit on ExpressLink and what are the benefits of using ExpressLink. And I keep having this architecture diagram in my mind, how much you have to build from scratch without ExpressLink, and how you have to worry just about your application if you're using ExpressLink. So that's actually a really good thing to keep in mind.
Right, exactly.
Yeah, so moving on a bit from ExpressLink, we did have Arm with us, talking about AWS IoT Greengrass and Parsec for security. So this was around edge software using Parsec, which is a core component of the Cassini project. I think this was a session moderated by our colleague Syed, and he spoke about the integration of Parsec with AWS IoT Greengrass and how developers are enabled to build secure solutions leveraging cloud-native tooling.
Yeah. And so let's see, where does that put us next? How developers can get started with AWS device software on embedded Linux. I don't recall who was the speaker there. I don't quite remember, but I do recall that it was an interesting session. But well, that's okay. We're
gonna have a look and find who was. Anyways, we can find it later.
Yeah, let's find it later.
Or maybe our viewers are actually going to find out
go
who
check it out.
Go check it out and put it in the comment section, for us to also hear. But I think we had a lot of open source and embedded Linux conversations throughout the 3 days, which is also really interesting. Then we had a talk about IoT developers innovating on AWS with CoAP.
Yeah.
And I think this was moderated by Nenad. Again, a very interesting session on using CoAP and what ClickAttack did there.
Yeah. very nice work from Plicatech. Yeah, yeah.
Absolutely, yeah. And we did have some episodes on Meta, for example, the offerings and the role of cloud for Meta devices.
That one I better remember because I think I moderated that one.
Yeah.
So yeah, Espresso joined us to talk about Matter and some of the offerings they have. For Matter, they do have a Matter compatible chipset, an ESP32 with Matter capabilities, and really it was interesting to talk with them about how AWS really plays a role for Matter devices, especially for the fact that AWS has a private CA service that actually plays really well into the attestation needed for Matter devices, and so Espresso utilizes that for their Matter devices. But yeah, it was a really great session from Espresso.
Yeah, absolutely. And I think they have a demo also here at the AWS booth, which was really interesting. I stopped by yesterday and I had a look at it. So it was a lamp controlled by a mobile app, everything running in a local network, and it was running over, using the Meta standard of implementation. So it was IP following. I mean, the protocol was IP, and it was built using the Meta standard, which was quite interesting.
Yeah, it's a great demo, and we've had quite a number of demos here at the AWS booth. We can see them from our point of view, but just in Espresso's was quite great because they were using products from different vendors, and which is the whole point of Matter, is that you can have interoperability between different vendor products. So it's really cool.
Yeah, right. I mean, Meta is fascinating. I think we're going to keep hearing about it in the days and months to come. So really excited about that. Right, and then we had a conversation on securing IoT with secure elements step by step, and then we had intrinsic ID also here.
Yeah.
With their unclonable identities. That was really interesting.
Yeah. So another theme I think throughout the live sessions over the last 3 days that we've done is security. The more sessions that we've done, security really sort of rose to the top as far as a topic, and both of those sessions, both with microchip and with intrinsic ID, microchip with the AT ECC 608 product, and then intrinsic ID with their really unique puff technology to bring security really to the edge devices, and really great stuff.
Right, and we've had intrinsic ID also in our IoT Builder session previously.
That's right.
So whoever is interested in hearing more about them should also rewatch our episode of IoT Builders. You can find it in the playlist on our YouTube channel.
Yeah, it's worth pointing out. Yeah, this is a special live stream from Embedded World over 3 days. But really, we have our weekly IoT Builders live stream as well, and so we'll have a lot of the similar topics and guests, but join us weekly for the live stream with IoT Builders. Yeah.
Right. So what else did we have? We had some more FreeRTOS LTS sessions. We spoke about SESIP.
Oh yeah, security standard for internet or IoT devices, basically.
Right.
And so FreeRTOS is now CSIP certified, I think to level 2. And working on level 3, I believe. So that's really great. And then finally, we wrapped it up on day 1 with building the badge. So this was a 3-part series that we did each day. Building the badge. This is again an ExpressLink oriented session about some engineers at AWS actually using ExpressLink for this virtual badge or this hardware badge use case, where they actually embedded an ExpressLink into an electronic badge, and kind of their whole process through building it and programming it and then using it. So really a great series there. But that was that wrapped up day 1.
Yeah, exactly. I mean, what I found really interesting about the badge project was, how Joe showed the hardware. I really love to see that hardware goes through various iterations, just like software does. You have like the MVP, which is a little bulky, and then it gets leaner and smaller and nicer. So Yeah, very interesting talk. To watch it.
That was very insightful.
Right, and that brings us to today too.
Okay, so this was yesterday.
Yeah, so this was yesterday, and it was a day focused again on observability and security. So we had, we had our first session starting really strong with Percepio.
Yeah.
So we had Johan and Mike from Percepio talking about their tools for observability, meaning Tracealyzer and DevAlert. Really good tools. We had a conversation with Richard Barry this morning about that as well. So it's a really difficult problem to crack, and Percepio is doing a really great job with these tools. So then we moved on again towards open source, and we spoke about open source software for connected vehicles.
Yeah, this was a overarching theme of day 2 yesterday. Was the software defined vehicle, the connected vehicle, everything in automotive basically.
Right, exactly. So this was a project by Luxoft, I believe. So we had Amund there, Director of Research and Development at DXC, it was a talk around what happens at the edge, what happens in the cloud backend, and the data management aspects of the connected vehicle.
Yeah, and then we learned a lot about this open consortium called SOFI, which is very interesting, and I'm also seeing around embedded world quite a bit. SOFI is at the ARM booth. SOFI is, I keep seeing the name around, and that's the work being done from Linaro. So that was a really great session as well.
Yeah, absolutely. And we moved on to more FreeRTOS talk about FreeRTOS for industrial automation with OPC UA. And here we had, we had BNR, and we had our colleague Adrian as well, from the partner SA team of AWS, talking about collaboration between AWS and 7 leading industrial automation and semiconductor companies, and how to accelerate, IT/OT.
Yeah, that was a nice session. I actually moderated that one, so it was quite good. Let's see. Then we had a session on embedded device CI/CD with virtual hardware and device advisor.
Yeah, so I was the moderator of that one. It was a great session with a senior cloud engineer at Arm, Elam, and also with David Walker, solution architect at AWS. So Elam gave an introduction into AVH and what it is useful for, how developers can move faster with it when they don't have the hardware at hand and they start developing their IoT solutions. And then David walked us through a nice CI/CD pipeline and how you can, build your code, get it deployed, get it, packaged, get it deployed to the virtual hardware, and then run your integration tests against Device Advisor. And then afterwards, when you're ready, you can push the image to your production devices.
Yeah.
Pretty neat, very interesting conversation there as well.
Yeah. Then we we hooked up with Sternum on their FreeRTOS based eval kit, which is really great. I think you hosted that session, didn't you?
Yeah. I hosted that session as well. It was a session with Leon, the CTO of Sternum IoT. He walked us through the reason why runtime protection is challenging and what runtime protection is, and how Sternum is offering a solution that mixes security and observability in order to cater for all the challenges that we encounter in constrained IoT devices out there in the field, with everybody just up and ready to hack them, and that's something that no manufacturer actually wants.
Right. Yeah. Really important.
They introduced out their FreeRTOS eval kit.
Which I'm excited. I'm excited to get my hands on one.
Yeah, me as well. So developers can also just go to the website of Sternum IoT and have a look for the FreeRTOS based eval kit.
Yeah. Let's see. Then Eurotech checked in with their Reliagate Edge IoT gateway integration with AWS IoT Greengrass with zero touch provisioning. I missed this session. Did you see this one?
I have not seen this session, and I'm going to catch up on the episode. But I did meet Marco because he had a session at the Congress, the Mended World Congress, and he spoke exactly about this zero touch provisioning and about how to leverage Greengrass. And he actually showed a very interesting mobile app that an operator can just take and with like 3 clicks, the device is already provisioned and connected to AWS IoT and to Greengrass. Which was really very, very impressive work, right? So it's about onboarding without any manual intervention, and of course also having devices. But when devices are shipped for the first time or when devices are replaced, this actually can come in handy. So yeah, good stuff. They also have a demo here, I think, in our area.
Oh yeah, exactly.
Cool.
Oh, and then we had the cloud native car with Sophie and Lenaro. So I think I messed up the previous session. It wasn't with Lenaro. It must have been a different session with
It was
Arm.
with Luxoft, I think. Yeah, it was with Luxoft.
Oh, Luxoft. Oh, my
Right.
apologies. Yeah, so I said it was Lenaro, but actually, the session with Lenaro came after Eurotech. Okay.
Right.
Yeah. So
Yeah.
that, like I said, Sophie has become kind of a theme through some of our sessions here, and the cloud native car with Sophie was from Lenaro. Both Andrea and Grant joined me for that discussion, and that was really enlightening, and really learned a lot about Sophie and what it means to have software-defined vehicle, which I think is a new term we're using these days. IoT device on wheels.
Oh wow, interesting. And so, what is this project, Iceberg Blueprint?
So this project, Iceberg, is basically provides a blueprint for how to create a software-defined vehicle. So it literally runs in AWS, and you can start developing software that ultimately will find its way into a vehicle, and do it in a very methodical and safety-oriented way. So using a lot of the cloud practices that DevOps engineers use, but really with ultimately the vehicle as the target.
Okay. Well, super interesting. Yeah, really nice, cool stuff. Right, and then we moved on to AGL.
Yeah, automotive grade Linux. That's
exactly.
right. Yeah, and we had Walt and Jan Simon join us for that, and Nenad hosted that one, I believe. And that was a really great session to learn more about automotive grade Linux and all the great open source work that that team is doing.
Yeah, I believe they're using the Okta project as well, right?
That's
for
right.
This work. Really, really interesting stuff. Then we had Open Synergy, again, an automotive talk about how to develop automotive solutions with hardware abstraction techniques. Very important as well. So it was around open standards, right? And how to develop with open standards and, bridge the gap between the cloud and the edge, more or less.
Yeah.
Right. So
that leads us to FiTech zones for rapid development and cloud-connected industrial machines. And this is another session I missed that I want to go back and catch, but it looked quite interesting. Did you catch any of this one?
No. So I also did not catch this one. I did look briefly through the description, and it is about, again, making the developer experience easy for connected industrial automation. But yeah, I encourage everybody, including ourselves, to go back to the episode and watch it. I mean, we had so many sessions throughout these 3 days that I think everybody, including us in the room, need to catch up on everything that has happened.
Yeah, there's sometimes we had to actually eat. I think it was part of the problem. So we didn't catch everything.
Yeah, exactly. But I hope we made it exciting for all the developers out there.
Yeah.
It was really super exciting to meet so many partners and to meet so many people passionate about embedded and about cloud and building better solutions with IoT and for IoT.
Yeah. The next session of the day was quite an exciting one. One you hosted, and
Yes.
I was behind the scenes on, which was with Mender.
Yeah, so we had Joseph.
Very colorful character from Mender.
The head of developer relations from Mender. He came well prepared with a device that I almost stole from him, but eventually it didn't happen. And we spoke about system updates and application updates. What is the difference between the two? We also spoke about the difference between machine data and processing data, and where Mender comes into the picture, where AWS IoT comes into the picture, and how the two of them can be merged together to build device management, but also the IoT use cases.
Yeah, and that was really quite well delivered from Joseph. So
Yes.
it was very nice. Yeah, then I believe Joe joined us, Joe Zaliker from ClickAttack, to talk about AWS Device Advisor Test Framework, right?
Yeah. So I think this was a session moderated by our producer today, Syed. So he guided the conversation around Device Defender and Device Advisor, and how ClickAttack is leveraging both to build this certainty that the connection to AWS IoT works, certainty that actually publishing of data, subscribing to IoT topics, that everything is really there and working, while at the same time security is ensured by leveraging Device Defender. Also a really good session.
Yeah, then wrapping up day 2, which was yesterday, we had, actually, there was one more session. I was jumping ahead. We had a session around functional safety and functional safety tips for developers. And again, Syed, our producer today, was the host for that. And Andrew Longhurst joined us from Wittenstein to talk about developing with FreeRTOS and SafeRTOS for safety certified devices. So that was actually a really great session. It showed the depth that Wittenstein has around functional safety and all the standards that really matter a lot when it comes to functional safety, and how to approach that sort of daunting looking process of certifying your code for safety safety standards.
Yeah, I mean, I see that it's becoming more and more of a topic, functional safety, and it's also been a topic really heavily present at the Embedded World Conference. So at the Congress, there was an entire, stream on functional safety, which was also really interesting to see.
Yeah. Okay, now we can jump to building AWS IoT ExpressLink Demo Badge Part 2.
Yes.
So that wrapped up yesterday's live stream sessions, and it was really a continuation, obviously, from Part 1. That really got into a little bit more of the production of the badge, and in Joe's production line at home with some of his volunteers who were his kids on making badges beyond just a handful. And how do you make 100 or 200 devices in a way that's repeatable and easy when you have limited resources?
It's really interesting. I'm going to definitely go back and watch that one. Was it in his garage or was it in his apartment? That's the question now.
I'm not sure, but he's got some pictures of his assembly workers who look a lot like him.
Yeah, I see. Well, nice, very good. And this brings us to the end of day 2.
Yeah, so that was it for day 2, and then day 3 today. What happened this morning?
Yeah, so what happened this morning is that I had a very interesting session, recap of yesterday with Richard Berry. I think I mentioned this before. We looked through the sessions that were related to FreeRTOS, and he gave us some more insight into functional safety, some more insight into observability, monitoring devices, why it is important. So really good session. And then we started off in force with Memfault, right?
Oh yeah, Tyler joined us from Memfault, which was great. He and Nenad really had a nice session talking about device reliability engineering with remote debugging and monitoring at scale. And as as Tyler put it, debugging in production is just the norm for Memfault, and it was really fascinating perspective, and definitely something to look at. And Memfault looks like a great service for observability.
Yeah, very nice. I mean, I think this is something that sometimes falls through the cracks for developers who are focusing really on functional pieces.
Yeah.
Building this observability earlier on is a very important aspect. So definitely really good episode from Memfault. Right, and then we went on with ARM again, and we spoke about ARM virtual hardware again, and the Keil Studio desktop, which is based on VS Code, and it leverages also third-party extensions, as far as I know. So it is a toolkit that developers can actually use, for example, when interacting with AWS services as well.
Mm-hmm.
Right. So it really helps with CI/CD. Building your code using this ID and then getting it deployed really quickly to AVH. So also a really interesting conversation.
Yeah, a lot of development going on with Arm and AWS on a number of fronts. They've always been a really good partner in terms of FreeRTOS and Synthesis packs and all other types of things. And Keil Studio Cloud is really a cool development platform that you can really easily get started with embedded development. And you don't even really need hardware because they have
the simulator, the virtual hardware,
the ARM virtual hardware. So anyway, really great stuff, and glad Christopher Seidel could join us for that.
Yeah, absolutely. And this brings us to the session again on AWS IoT ExpressLink and building awesome products. This was a session that we had with Telit, right?
Yeah, now known as Telit Cinterion. So Telit, talked about their acquisition, and now they're known as Telit Cinterion. And they talked about the new board that they'll be releasing, the Bravo board, and the new ExpressLink module that they're also releasing. And so that was really interesting because it adds a Cat 1 cellular product to the ExpressLink family, and so now you can use Cat 1 globally with ExpressLink, and so isn't that cool?
Yeah, this is really cool. I mean, I've seen the hardware outside here in one of the demos. If you're still at Embedded World and you want to pop by, just come to the AWS booth and you're going to actually see a demo based on the hardware that Dan was talking about. So really interesting stuff. Right, then we spoke about FreeRTOS and open hardware.
Rick joined us, who's the CEO of the Open Hardware Group, talked a lot about RISC-V and about how the Open Hardware Group was formed and the reason for that. But they've also got a dev kit that will be coming out this year too, based on the Core 5, which is the core that they're developing around RISC-V, and it'll also include ExpressLink. Right. So this theme is just getting like almost overemphasized, but it's really it just shows how important ExpressLink is as a product. That'll be on the dev kit, and it'll be running FreeRTOS as well.
Yeah, I mean, I have to say there is so much hardware everywhere at Embedded World that I feel like a kid, in a candy shop. It's just like everywhere, different hardware, different solutions, different demos. It's a really, really, really cool event, so cool exhibition.
And it's getting easier to use it all too.
Yeah.
It used to be kind of a little challenging to get up and running on some of these tool chains and some of these processes that you had to go through. I think one big thing I'm seeing is it's getting so much easier to actually work with the hardware, and also most of it's connected.
Right. So it's about acceleration and about developer experience, how quickly you can get onboarded, how quickly you can get the tools, how quickly you can, when there is hardware shortage, how quickly you can still move on and move forward and produce and write code. It's really interesting. It's fast paced, definitely.
Yeah.
Right, so then we had a session about smart camera software frameworks, and it was again a session with Arm, where we spoke about the new software developer paradigms related to the smart cameras, and I think this was a session that Syed moderated.
Yeah.
But also a very interesting session. I'm definitely going to go back and watch that, for sure.
Yeah. Let's see. Then we had open source and IoT and Edge. Oh my! I did not see this one, but it looked very entertaining and insightful. It was with Frederic from the Eclipse Foundation,
right?
And it was all about IoT and edge computing, of course.
Right. An open source project.
Yeah, of course, open source with the Eclipse Foundation.
Yeah, so apparently Eclipse Foundation is the home to more than 425 open source projects.
Oh, that's a lot.
So that's
I knew of some, things like Tahoe and Mosquito and those types of, MQTT technologies are Eclipse Foundation projects. A lot of people think of of Eclipse as just the IDE.
Right.
But in fact, they have a whole IoT, work group. That has all of these IoT projects, many of which are embedded into the frameworks we all use.
Right, absolutely. So yeah, very interesting episode there. And then we moved on again to ExpressLink.
Oh my gosh.
It feels like we never moved away from ExpressLink.
I don't think we
did
ever got that far. Yeah. So yeah, ST joined us and talked about STM32 microcontrollers as the host processors for host applications using ExpressLink. And ST has just done some fantastic work creating a new iCube module, the iCube ExpressLink, which makes it super easy to take an STM32 microcontroller, write your application, and literally zero code. So we went from 10 lines of code with ExpressLink now with this ST package to zero code to connect to AWS IoT. Really some nice stuff. They've developed it in a Simsys pack framework, and they're using FreeRTOS for many of the examples. And you know, a lot of their Nucleo and Discovery boards come with sensors already, already on board. And so, this work that Slim has done around the, around the Simsys pack and around this iCube framework just makes it so much easier to use it all and just interface immediately with ExpressLink.
Yeah, so really cool stuff. And then, of course, we concluded with nothing else but the badge project.
Right,
so,
building the badge, part 3.
Yeah. So I think that this was basically, the summary that of the 3 days at Embedded World. I'm hoping that everybody really watched us, and if not, we'll go back and watch all the episodes and try to, catch up. What else did we have around these 3 days that we want to talk about?
Yeah, so we're positioned in the center of the AWS booth here at Embedded World in Hall 4, and we're surrounded by demos. And a lot of these demos have been really quite interesting and interactive, and we've seen a lot of foot traffic through the booth. So that's pretty exciting. We've also had some talks, some expo talks. So
Right.
I know that you delivered an expo talk today.
Yeah, absolutely. So I had a talk today on AVH and CI/CD and IoT Core Device Advisor. It really was about how to build a Yocto image and how to package that image and deploy it to Arm virtual hardware.
Yeah.
And then from there, how to configure a little application to go and connect to the device advisor endpoint, execute and run integration tests. And if the integration tests are successful, then the pipeline can move on and the firmware can be deployed on production devices. So yeah, I had fun with this session. Lots of engagement, lots of people interested in Arm virtual hardware and third-party hardware and so on. So I would say it was a really quite a good session.
That's great. That's great. Yeah, I had a session yesterday on, are we saying this word too much? ExpressLink. Yeah, it was a really nice session as well. I know that Richard Berry had a session talking about FreeRTOS, and there were a number of other other sessions around. So it was great. We had over the last 3 days, talks and interaction with developers and other builders. Also in the AWS booth, we also have an installation that features hardware from all of our partners, and this is qualified hardware that have run through different tests, and it's called the device wall. And so we have the partner device wall here in the booth, and that's really nice to see because as a cloud company, sometimes people think, well, how much do you really know about devices? Well, just take a look. These are all qualified devices that work with AWS IoT, and it's really a nice showcase.
Yeah, and in order to qualify your device, you actually can use IoT Core Device Advisor, and you can run the qualification test suite, and then download the report, and then use that report in your application to qualify your device. So this is also a really interesting aspect.
Yeah. All right. So I think that's it for us. This was really fun doing this back-to-back live streams. Over the course of 3 days. We've really enjoyed meeting all these partners and collaborators, And I hope you've enjoyed it too. We're going to continue our live stream series weekly, but this was, a really great special event at Embedded World. So I had fun. How about you?
Yes, it was a lot of fun, really engaging, great community, great conversations, great partner meetings, great participation, in our live stream. Join us for our weekly episodes of IoT Builders. You can scan this QR code and it will take you straight to where, you need to be.
There you go.
Yeah, and if you have any, desire content that you would like to have from us, then let us know either via dev.to or let us know via YouTube comments, and we are more than happy to basically put that together. So yeah, reach out to us, talk to us, and otherwise it's been a real pleasure, streaming this from Embedded World, and have a great rest of the day.
So long for now.